The 3I Atlas mission has once again turned the eyes of humanity toward the moon, reigniting an era of exploration that is both scientific and symbolic. The mission, driven by the international consortium known as 3I, short for the International Interplanetary Initiative, represents the culmination of years of collaboration among engineers, astronomers, and policymakers across multiple continents. ATLAS, standing for Advanced Topographical and Lunar Analysis System, is not simply another robotic surveyor or scientific probe. It is a statement of intent. Its return to the lunar surface signals that humankind is not yet finished with the moon. There are still questions to answer, maps to refine, resources to study, and technologies to test that will determine the shape of our next century beyond Earth. Before we start, hit the like and subscribe buttons for more exclusive news. The moon has long served as a kind of mirror, reflecting not only sunlight but also humanity's ambitions. Decades after the first human footprints marked its gray dust, new missions like 3I Atlas show how much has changed in both motive and method. This mission is not fueled by competition, nor is it a mere symbol of prestige. It is built around cooperation and long-term vision. The 3I Consortium brings together the best aspects of multiple space agencies and private industry. Rather than racing toward the moon for national glory, they are building the foundation for a sustainable, data-driven future in cislunar space. The Atlas component embodies that purpose, combining an array of instruments to map, monitor, and model the moon in ways that were impossible even a decade ago. The core of 3I Atlas's purpose is the study of lunar resources, particularly those in the permanently shadowed regions near the poles. Scientists have long theorized that these areas may contain reserves of frozen water, hydrogen, and other volatiles, remnants of comets and asteroids that have accumulated over billions of years. ATLAS is designed to penetrate the mystery of these shadowed craters using a suite of spectrometers, radar imagers, and subsurface scanners capable of detecting molecular signatures beneath layers of regolith. The data from these instruments will be used to construct three-dimensional models of the moon's polar geology, revealing where useful materials might be found and how they might be extracted safely. This is not merely scientific curiosity, it is a step toward creating the infrastructure needed for permanent lunar habitation and future missions deeper into the solar system. To understand why 3I Atlas matters so profoundly, one must consider the context of modern space exploration. The moon has become a proving ground for technologies that will someday be used on Mars and beyond. Everything from autonomous navigation to in situ resource utilization, ISRU, must be tested in a real environment, and the lunar surface provides that opportunity within a manageable distance from Earth. Atlas's sophisticated sensor systems will collect continuous, high-resolution data that can be used to train AI algorithms for terrain mapping and hazard avoidance. These algorithms will not only guide future lunar landers and rovers, but also form the backbone of autonomous exploration throughout the solar system. But 3I Atlas is not just about technology, it is also about stewardship. The mission's planners have been keenly aware of the ethical implications of returning to the moon. As multiple nations and corporations prepare their own missions, there is an increasing need to establish standards for exploration that respect both the scientific integrity of the lunar environment and the shared heritage of humanity. 3I's approach integrates environmental monitoring into the very fabric of Atlas's operations. Instruments on board will measure the effects of landing and mobility on the delicate lunar dust, track temperature fluctuations caused by human activity, and evaluate how equipment might alter the moon's fragile surface chemistry. In this way, 3I Atlas serves as both explorer and guardian, setting precedents for responsible conduct in the new space age. The scale of 3I Atlas's ambition can be seen in its technical architecture. The lander, designed through joint efforts among European, Asian, and North American engineers, carries not only its own suite of sensors, but also deployable micro-rovers and stationary instruments that can form a distributed observation network. This modularity allows Atlas to function as a small-scale lunar observatory. Each component feeds data back to the main hub, which then relays it to Earth in real time through a dedicated relay satellite positioned in lunar orbit. The network's data synchronization system enables unprecedented precision in mapping and environmental analysis, turning the mission into a living laboratory for remote sensing and planetary science. The name Atlas is particularly fitting. Just as the mythological Atlas held the heavens upon his shoulders, this mission bears the weight of humanity's future on its mechanical limbs. Every pixel captured, every spectral line analyzed contributes to a growing body of knowledge that will one day make lunar industry and settlement possible. The mission's visual mapping systems are expected to produce the most detailed topographical maps of the moon ever created, with resolution fine enough to distinguish features only a few centimeters across. These maps will not only refine our understanding of the moon's geological history, but also help engineers plan the safest and most efficient routes for future robotic and human missions. One of the most remarkable aspects of 3I Atlas is its emphasis on real-time adaptability. Unlike earlier missions that followed rigid, pre-programmed instructions, Atlas can modify its objectives dynamically based on conditions it encounters. Using machine learning algorithms trained on Earth, the mission's onboard computer can identify interesting geological formations or anomalous readings and decide whether to investigate further. This ability to make autonomous scientific decisions marks a turning point in robotic exploration. It reduces reliance on delayed human commands and paves the way for deeper missions where communication lag would otherwise limit responsiveness. Another crucial element of 3I Atlas lies in its examination of lunar magnetism and radiation. The moon's magnetic anomalies have puzzled scientists for decades. Atlas carries instruments that will measure localized magnetic fields and their interaction with solar wind particles. This data will help unravel how certain regions of the lunar crust retained magnetism while others did not. Understanding these processes is vital for constructing safe habitats, since areas with higher natural shielding could become prime locations for future bases. Furthermore, Atlas's radiation sensors will gather data crucial for designing protection systems against cosmic and solar radiation, a necessity for both machines and humans planning to stay longer on the moon. The mission's propulsion and landing systems also showcase innovations that push the boundaries of what has been achieved before. Atlas employs a hybrid propulsion design combining traditional chemical engines with electric thrusters. This allows for highly efficient orbital adjustments and precision landings. Its descent was guided not only by radar and LiDAR, but also by optical navigation that compared live images to preloaded maps. This multi-layered navigation ensured a pinpoint landing in a scientifically valuable yet safe region. Such technology will become standard for future missions, where accuracy means the difference between success and disaster. As 3I Atlas conducts its operations, its presence is reshaping international collaboration in space. For the first time, data from a lunar mission is being shared in real time among multiple partner institutions without delay or restriction. Universities and research centers across the globe have access to the same streams of data, fostering a model of open science that transcends borders. This openness is redefining how space exploration can serve as a unifying endeavor rather than a divisive one. By inviting participation from smaller nations and independent research groups, 3I has created a truly global laboratory on the moon. There is also a profound symbolic power in what 3I Atlas represents. The moon has always been humanity's first frontier beyond Earth, but it also serves as a metaphor for unity. To see an international mission operating there, combining resources and intellect from many cultures, sends a message that cooperation is not only possible, but essential. Every time a signal returns from the lunar surface, it reminds us that the barriers of nationality and ideology fade in the face of shared curiosity. The data pouring in from Atlas are not just scientific numbers. They are threads weaving together the collective story of humankind's reach into the cosmos. The implications of 3I Atlas extend beyond science and politics into the realm of philosophy and identity. Humanity has always defined itself by its relationship with exploration. To explore is to ask who we are and what we are capable of. In returning to the moon with a mission that blends intelligence, compassion, and precision, we are also revisiting the roots of our technological and imaginative spirit. Atlas stands as a bridge between the ancient dreams of the stargazers and the practical engineering of the 21st century. Its sensors and circuits are guided not only by logic, but by the same wonder that once inspired poets and navigators to gaze skyward. The technological implications are staggering. Every component of 3I Atlas is an experiment in durability and efficiency, The harshness of the lunar environment, its vacuum, temperature extremes, and constant bombardment by micrometeoroids makes it an unforgiving test site for new materials. Atlas's structure includes self-healing composites and radiation-hardened electronics designed to operate for years without maintenance. Success here will inform the design of next-generation spacecraft, habitats, and even terrestrial systems meant to withstand extreme conditions. In this sense, what happens on the Moon will shape industries far beyond space exploration. One of Atlas's most ambitious experiments involves the study of lunar dust dynamics. Lunar dust, composed of jagged microscopic particles, has long been a challenge for missions because it adheres to everything and wears down equipment. Atlas carries an experimental system to observe how dust behaves during movement, landings, and thermal changes. By monitoring this in detail, the mission aims to develop mitigation techniques that will be critical for the safety and longevity of future operations. Understanding how dust interacts with machinery and human activity could lead to new coatings, electrostatic systems, and filtration methods that will benefit all future lunar missions. At its heart, the 3I Atlas mission is about knowledge, the slow, deliberate unveiling of a world that has always been close yet enigmatic. The Moon preserves within its layers the history of the solar system itself. Every crater is a record of cosmic events. Every mineral deposit a clue to ancient processes that shaped not only the Moon, but Earth as well. By gathering and analyzing this data, Atlas contributes to understanding planetary formation, asteroid impacts, and the conditions that allowed life to thrive on Earth. It turns the Moon into an open archive of celestial history, accessible for the first time with clarity and depth. Beyond the strictly scientific, 3I Atlas is pushing the boundaries of public engagement. The mission includes an outreach component that allows people around the world to experience its discoveries in near real time. Interactive visualizations of lunar data, transmitted through open platforms, invite students, artists, and enthusiasts to explore alongside scientists. This democratization of discovery has transformed the way people connect to space exploration. No longer distant spectators, they are participants in the unfolding narrative of exploration, their imaginations expanding alongside the mission's findings. The logistical complexity of coordinating 3I Atlas cannot be understated. Dozens of nations contributed components, each built to exacting standards, yet integrated seamlessly into the whole. The launch itself represented a choreography of precision. The alignment of orbital windows, fuel optimization, and real-time adjustments based on telemetry from multiple control centers. Once in lunar orbit, the mission stages unfolded with clockwork accuracy, culminating in a landing that marked not just a technological triumph, but a testament to what cooperative effort can achieve. The synergy between human ingenuity and machine intelligence was on full display, a rehearsal for the grander challenges that await beyond the Moon. While 3, Atlas's scientific instruments capture attention, its communication system is equally groundbreaking. It uses quantum encrypted data links to ensure absolute security in transmission, a first for any lunar mission. This technology safeguards sensitive research while demonstrating how future interplanetary communication networks might operate. The inclusion of quantum encryption also highlights how space exploration drives advancements that ripple into everyday life, influencing everything from cybersecurity to telecommunications. Another vital component of the mission is its thermal management system. The Moon's temperature swings between blistering heat and freezing cold, and Atlas uses a smart thermal control grid capable of redistributing heat in response to environmental conditions. This adaptive system not only conserves energy, but extends the lifespan of instruments. The lessons learned here will be invaluable for maintaining long-term surface installations, where stable temperature control is essential for both human comfort and machinery reliability. Perhaps the most profound contribution of 3I Atlas is its approach to resource mapping for sustainable exploration. Rather than treating the Moon as a site to exploit, the mission frames its study within a philosophy of renewal and balance. Its instruments measure not only where resources exist, but also how their extraction might affect the environment. This level of foresight represents a moral and scientific evolution in how humanity approaches new worlds. The emphasis on sustainability ensures that future missions will build not on depletion, but on harmony with the extraterrestrial landscape. As Atlas continues to operate, Its orbiters and surface units coordinate with each other in a constant exchange of information. This interplay between ground and sky forms a self-correcting feedback system, enabling the mission to adapt to unforeseen challenges. Such resilience mirrors the human spirit itself, the capacity to endure, to learn, and to improve. Each calibration and adjustment echoes the adaptability that has always defined exploration, reminding us that discovery is not a straight path but a series of evolving insights. The implications for future missions are immense. The data gathered by 3i Atlas will guide the placement of future landing zones, resource depots, and potential habitats. Engineers will use its maps to design rover paths and habitat foundations, minimizing risk and maximizing efficiency. Scientists will use its geological and chemical analyses to refine models of lunar evolution, which in turn inform our understanding of terrestrial and planetary processes. And policymakers will draw on its example of collaboration to craft frameworks for peaceful, cooperative exploration beyond Earth. At a deeper level, 3i Atlas rekindles a sense of wonder that had dimmed in the decades after the first moon landings. It reminds us that the moon is not a relic, but a frontier still alive with potential. Every new measurement, every image transmitted, reinforces that the cosmos remains a place of discovery, not merely nostalgia. The mission speaks to something primal in human nature, the desire to reach out, to touch the unknown, and to bring meaning back from it. In doing so, it renews our relationship with the universe and with each other. The success of 3i Atlas also underscores the growing integration of artificial intelligence into exploration. Its ability to learn from its environment and optimize its operations in real time represents a major leap in autonomy. This not only reduces operational costs, but also allows missions to push further with less human oversight. The same systems being tested on Atlas may one day guide robotic explorers across the icy moons of Jupiter or the dusty plains of Mars. It is a small step toward the age of self-sufficient machines that can expand the human presence across the solar system. Moreover, the mission's findings could redefine economic possibilities. By accurately mapping water ice, metallic ores, and other usable materials, Atlas provides the groundwork for future industries in space. These resources could fuel rockets, build habitats, or even support manufacturing off Earth, reducing dependence on terrestrial supply chains. What began as exploration could become the seed of a new economic sphere, transforming not just how humanity explores, but how it lives and works beyond the planet. Every milestone of 3i Atlas resonates with symbolic depth. When its instruments hum across the silent lunar plains, they echo the collective heartbeat of countless engineers, scientists, and dreamers. When its sensors detect the faint glimmer of ice in shadowed soil, it captures not just a scientific triumph, but a moment of human destiny, a step closer to becoming a multi-planetary species. And when its data streams back across the void, weaving through satellites and fiber networks, it connects the moon's distant silence to the pulse of civilization. There is poetry in this return. The moon, once a silent companion to humanity's nights, is now an active partner in our journey of progress. 3. Atlas is the medium through which this dialogue continues, transforming centuries of myth into measurable, tangible truth. Its instruments listen to the whispers of the lunar soil, and through them we hear the echoes of our own curiosity. It is an act of reconnection, a renewal of vows between humankind and the universe. As the mission proceeds, it continues to reveal layers of complexity within the moon's landscape. Subtle shifts in composition, micro-craters hinting at long-forgotten impacts, and traces of volcanic glass that speak of ancient fire. Each discovery adds to the mosaic of knowledge that 3i Atlas is assembling. It is a reminder that exploration is not about finding the extraordinary, but about recognizing the extraordinary within the familiar. The moon, once thought to be barren and static, is proving to be a world full of motion, memory, and potential. The broader implications for science education and cultural identity are equally significant. 3i Atlas has already inspired a new generation to study science, technology, and engineering. Its open access approach allows classrooms across the world to follow its progress, analyze real data, and participate in the excitement of discovery. For many, this mission represents a return of purpose, a shared project that transcends divisions and points toward a collective horizon. The moon, once the dream of a few, is once again the dream of everyone. The light from Earth gleams faintly on the hull of the 3I Atlas lander as it continues its quiet labor on the moon, each movement deliberate, each data pulse a fragment of human will encoded in machinery. The mission has entered a rhythm now, the long cadence of scientific work unfolding in silence. Solar panels tilt with the slow precision of choreography, calibrating their angle to the cold sun. Instruments swivel to catch the faintest signatures from beneath the surface, and the telemetry flows, steady, immaculate, across the gulf of space. Every moment is both an act of engineering and a meditation on distance. The moon, so close in the night sky and yet so unreachable by touch, has become once again a laboratory, a threshold between what we know and what we have yet to understand. Among the most fascinating aspects of 3I Atlas is the way it redefines the concept of time and exploration. Earlier missions worked in bursts, brief stays, fast orbits, rapid measurements. Atlas, in contrast, is designed for endurance. Its instruments are made to operate through the endless cycles of lunar day and night, surviving 2-week stretches of shadow when temperatures plunge to near absolute zero. To endure such extremes, its systems rely on phase change energy storage and advanced thermal coatings capable of holding latent heat as though hoarding the memory of sunlight. The goal is not a sprint, but a sustained presence, a commitment to patience that mirrors the moon's own slow evolution. In this patience lies a new form of exploration, not conquering, but listening. Each lunar day brings a different face to the mission's surroundings. As the sun rises, casting long blue shadows across craters, sensors awaken and begin measuring temperature gradients, reflectivity, and radiation flux. The data paints a living portrait of the moon's skin, revealing how its surface breathes under the onslaught of sunlight and cosmic wind. The regolith, long thought inert, behaves almost like a living membrane, expanding and contracting, releasing faint gases, conducting heat unevenly through layers of crushed rock and dust. These processes, invisible from Earth, may hold keys to understanding how other airless bodies evolve under constant bombardment from the cosmos. In studying the moon's reactions to light, 3I Atlas is effectively studying the heartbeat of a world. The mission's micro-rovers play a vital role in this unfolding study. These small, spider-like machines roam a few kilometers from the main lander, moving slowly but with remarkable agility across uneven terrain. Their legs are fitted with tactile sensors that register the softness or rigidity of the ground, translating texture into data. Through them, 3I Atlas perceives the surface not just as an image, but as a touch. Every grain of dust that shifts under their weight tells a story of erosion, impact, and time. Together, the rovers and lander function like the senses of one collective organism, probing the moon's skin for signals of its past and whispers of its potential. The 3I Atlas mission also experiments with a concept that may define future planetary exploration: symbiotic autonomy. Rather than a single robotic hierarchy, the mission operates as a network of semi-independent entities that communicate and collaborate. When one unit encounters a problem, a power drop, an obstacle, a thermal anomaly, it can transmit data to the others, allowing the collective to redistribute energy, alter routes, or modify objectives. This cooperative behavior is a precursor to the robotic ecosystems that will one day accompany human explorers on Mars or the icy moons of Jupiter. It transforms the act of exploration from a linear command chain into a conversation among intelligent agents. Deep beneath the regolith, Atlas's instruments are detecting subtle differences in density and electromagnetic response, suggesting hidden layers of material composition. Some of these findings hint at past volcanic activity long after scientists believed the moon had gone cold. Traces of ancient lava tubes, pockets of frozen gases, and irregular mineral distributions paint a picture of a world that was once dynamic, even turbulent. The revelation that the moon may have retained internal heat far longer than previously thought opens new questions about its geologic evolution and its relationship with Earth. Each measurement adds a brushstroke to the portrait of the moon as a companion planet rather than a mere satellite. In its pursuit of knowledge, 3I Atlas has also become an experiment in endurance of the human mind. The mission control teams scattered across continents maintain a near ritualistic schedule. Scientists and engineers synchronize their lives to the lunar day, working through long hours when the moon is in sunlight and entering a quieter phase during its long night. It is as if a fragment of humanity's rhythm has been transplanted off-world. Across laboratories and observatories, people watch the slow rotation of a crater or the changing shadows along a ridge, as though observing a distant friend breathe. The connection between machine and human is intimate, threaded through data and time delay, forming a relationship unlike any before. The moon's poles, where Atlas operates, are some of the most hauntingly beautiful places in the solar system. The sunlight there strikes at low angles, casting permanent shadows that never feel the warmth of day. Within these black hollows, the temperature never rises above freezing, yet it is precisely in these darknesses that the mission finds its richest promise. Instruments tuned to detect the faint reflection of radar signals reveal bright patches that could signify buried ice. If confirmed, these reserves represent not only a resource for future explorers, but also a record of cosmic history, preserving in frozen form the chemistry of the early solar system. The moon's darkness, paradoxically, may hold the brightest hope for our understanding of planetary origins. While 3Y, Atlas's public image, is dominated by its technological prowess, there is an artistic quality in its execution that cannot be ignored. Every camera frame it captures is a study in contrast and silence, a dialogue between light and emptiness. The images sent back to Earth have become more than scientific data. They are portraits of solitude, the kind that evoke both humility and awe. Many artists and writers have drawn inspiration from these stark vistas, translating the raw geometric beauty of the lunar surface into new forms of expression. In this sense, the mission bridges the scientific and the poetic, reaffirming that exploration has always been as much about feeling as about fact. As Atlas continues to explore, one of its long-term objectives involves creating a high-precision gravitational map of the moon. This task, though less glamorous than discovering ice or minerals, is crucial for future navigation. The moon's gravitational field is irregular, distorted by mass concentrations beneath the surface known as mascons. These hidden anomalies can subtly alter the trajectory of orbiting spacecraft, complicating landings and transfers. By mapping these variations in exquisite detail, Atlas provides a foundation for the precise navigation of future missions. Every gravitational measurement becomes a guidepost for the next generation of explorers, ensuring that when they set foot again upon the lunar soil, they will do so with knowledge as their compass. The mission's success so far underscores the triumph of collaboration over competition. The data infrastructure supporting 3I Atlas spans continents and time zones. Laboratories in Africa, South America, and the Middle East contribute equally alongside established space powers, demonstrating that the frontier of space no longer belongs to a few. This inclusiveness is perhaps one of the mission's quiet revolutions. It reflects a new ethos in exploration, one where discovery is a shared language rather than a guarded secret. The moon, through Atlas, has become a meeting place of minds, a realm where humanity gathers to think beyond boundaries. Another groundbreaking feature of the mission is its capacity to perform on-site data compression and analysis using neural processing units integrated into the lander's architecture. Rather than sending raw data to Earth for processing, Atlas interprets much of it on location, reducing transmission loads and enabling faster insights. This on-site intelligence marks a leap toward autonomy, allowing missions to react immediately to findings without waiting for Earth-based confirmation. The implications reach far beyond lunar exploration. Such systems could one day guide probes exploring asteroids or distant planets where communication delays stretch into hours. While most attention focuses on what Atlas observes, equally fascinating is what it learns to ignore. Its learning algorithms constantly refine their focus, filtering out noise and irrelevant data. Over time, the system develops a form of intuition, an ability to discern which anomalies are meaningful. This adaptive intelligence, though purely mechanical, echoes the process of human discovery. It mirrors how scientists themselves sift through oceans of information to find the faint signal of truth. In watching Atlas learn, humanity witnesses a reflection of its own curiosity encoded in silicon. The moon's silence amplifies every motion of the mission. Without atmosphere, there is no sound, no wind, no erosion save that of time and radiation. When Atlas drills into the soil, its vibrations travel unimpeded, echoing faintly through rock that has lain untouched for eons. Each probe insertion, Each laser pulse, each radar sweep feels like a whisper in a temple. The instruments act as translators between the inhuman and the human, converting the moon's stillness into patterns we can read. In this transformation lies the essence of exploration, the act of giving voice to the voiceless cosmos. The findings from Atlas are already reshaping scientific models. The discovery of unusual isotope ratios in surface samples hints at interactions between solar wind and lunar minerals that could reveal how the sun's activity has changed over billions of years. By studying the imprint of ancient solar storms preserved in the regolith, scientists gain a time capsule of the solar system's energetic history. Such knowledge could refine predictions about space weather, a vital concern for future astronauts and satellites. The moon thus becomes a natural archive, and Atlas its careful librarian. Every day, the mission expands its field of study. Beyond mineralogy and topography, it examines how the moon's faint exosphere, the ghostly layer of gases surrounding it, changes over time. By monitoring traces of argon, sodium, and hydrogen, Atlas contributes to the understanding of how atmospheres evolve and escape into space. The moon, with its nearly vanished air, offers a perfect laboratory for studying the balance between gravity and evaporation, a process relevant to every planet and moon across the cosmos. These observations add yet another dimension to the mission's reach, showing how even the thinnest breath of gas can hold vast scientific meaning. The cultural weight of 3I Atlas cannot be separated from its science. In classrooms, in documentaries, in art installations, the mission's progress has rekindled the fascination that once surrounded the first lunar landings. Children trace the outlines of craters on interactive screens, following the paths of the rovers as though guiding them by hand. For many, Atlas is their first real-time experience of exploration, a shared event that binds generations through wonder. This collective participation transforms the mission into something larger than science. It becomes a living story, an act of continuity between the dreams of the past and the visions of the future. The moon, through 3I Atlas, has become more than an object of study. It is a partner in dialogue, responding through data to our persistent questions. The mission's instruments measure with exquisite sensitivity, but they also evoke a sense of humility. For every discovery, there are new mysteries, traces of elements that defy current models, patterns of radiation that suggest unseen processes. Each answer opens a deeper layer of inquiry, as if the moon itself were reminding us that knowledge is not an end, but a horizon. One of the most subtle yet profound aspects of the mission is its psychological echo on Earth. Humanity's gaze toward the moon has always been intertwined with introspection. As data streams in, it alters not just our scientific understanding, but our emotional relationship with space. People feel the presence of Atlas in the night sky, a small spark of human intelligence resting in the dark. The idea that a collective endeavor continues to function, alone but persistent, across that vast gulf instills a sense of resilience and belonging. It becomes a quiet affirmation that even in isolation, humanity endures. The engineering triumphs behind the mission are matched by their elegance. The rover joints use bio-inspired designs modeled after the flexibility of animal limbs, allowing smoother motion on rough ground. Sensors are embedded in soft polymer layers that mimic the sensitivity of skin. This biomimicry gives the machines a subtle grace, allowing them to navigate terrain not with brute force, but with finesse. In this way, 3I Atlas fuses technology and nature, demonstrating that progress does not always mean imitation of machinery. It can mean learning from life itself. Energy management remains one of the mission's constant challenges. During the long lunar night, when the sun disappears for nearly 2 Earth weeks, Atlas must rely on stored energy and heat reserves. Its systems enter a semi-hibernative state, maintaining just enough activity to preserve critical data and keep its electronics alive. When the first edge of sunlight returns, the lander slowly awakens, panels unfurling like petals. The sequence is almost organic, a rebirth enacted in machinery. This cycle of dormancy and renewal has given the mission an almost mythic rhythm, echoing the ebb and flow of life itself. As the mission endures, it begins to collect temporal data, patterns that can only be observed through persistence. Minute shifts in the regolith, faint glows caused by electrostatic discharge at twilight, variations in radiation levels with solar cycles. All these phenomena require time to reveal their significance. Atlas's longevity transforms it into more than a visitor. It becomes a resident observer. Through its patient watch, the moon ceases to be a static world and emerges as a dynamic, changing environment. The mission's greatest contribution may not be in the isolated discoveries, but in the continuity it establishes between moments. In a sense, 3I Atlas embodies the evolution of humanity's curiosity. The first explorers sought new lands. Now we seek new truths. The tools have changed. Sails have become solar arrays. Compasses have become star trackers. But the impulse is the same. The moon, which once symbolized unattainable mystery, now becomes a canvas for precision, intention, and shared aspiration. Through Atlas, humanity asserts not dominance but participation in the unfolding story of the cosmos. It is as though we are learning again how to speak the language of the universe, one measurement at a time. There is also a quiet poignancy in the realization that for all its technology, the mission's essence remains deeply human. The engineers who designed its arms and sensors infused it with their own sense of curiosity. The programmers who wrote its code gave it the logic of inquiry. And the observers who interpret its signals give meaning to the data. In this way, Atlas becomes an extension of human perception, a set of distant eyes and hands carrying our awareness into places where our bodies cannot yet go. The boundary between human and machine blurs. What we learn there, we learn through it. And in return, it learns for us. The moon's stillness has become a stage for one of the most profound experiments in coexistence between human intention and robotic independence. The mission demonstrates that intelligence does not need to mimic consciousness to be meaningful. The coordination between Atlas's components resembles an orchestra rather than a hierarchy, each instrument playing its part in harmony. From this emerges a new paradigm of exploration, one based on balance rather than command, responsiveness rather than control. Such harmony may one day define how humans and machines explore the universe together. As the mission delves deeper into its objectives, new questions arise about the limits of human reach. The moon, once the edge of ambition, now feels like the first step in a longer path. What Atlas accomplishes here will become the blueprint for operations on more distant worlds, where communication delays and harsher conditions will demand even greater autonomy. The technologies tested, self-learning systems, distributed robotics, adaptive energy use, will form the foundation for interplanetary settlement. In this way, the moon becomes both a destination and a rehearsal, a mirror and a gateway. The psychological impact of this ongoing exploration extends into cultural and philosophical dimensions. The mission's success challenges the notion that exploration must always involve physical presence. Humanity is beginning to accept that the extension of our senses through technology does not diminish our spirit, it amplifies it. The rovers and sensors of Atlas are not substitutes for human explorers, they are the vanguard, the first emissaries of thought beyond the body. This new mode of exploration redefines what it means to be present, suggesting that consciousness itself can travel through data and signal as effectively as through flesh and bone. In this transformation, a new narrative is being written, one where the boundaries between science and story dissolve. Each day's report from Atlas reads like a chronicle of discovery, yet beneath the numbers lies a quiet lyricism. The moon's surface, once described in myths as silver seas and mountains of glass, now speaks in the language of spectra and coordinates. Yet the wonder remains the same. In measuring the moon's dust, we measure our own longing. In tracing its contours, we trace the outlines of our desire to know. The evolution of the mission's communication protocols is another subtle triumph. Its signals travel across the vast emptiness between worlds, encoded in light. As data moves from moon to satellite to Earth, it crosses thresholds of delay and distortion. Engineers on Earth have learned to read these distortions as though they were fingerprints, unique to each transmission path. Over time, the mission has taught humanity not only about the moon, but about communication itself, the art of conveying meaning across isolation. It is an art we may need more than ever as we expand our presence among the stars. The longevity of 3I Atlas ensures that its influence will endure well beyond its operational lifetime. The data it gathers will feed countless studies, guiding missions that will follow in its path. Long after its solar panels fade and its instruments fall silent, its presence will remain woven into the infrastructure of exploration. The maps it created will guide rovers. The algorithms it trained will navigate ships. The philosophies it inspired will shape how humanity treats the worlds it touches. Even in eventual stillness, Atlas will continue to speak, its legacy embedded in the next generation of explorers. What the mission is doing to the moon is both simple and profound. It is awakening it in our collective imagination once again. The moon, dormant for decades in the shadows of human memory, is alive now in our sensors and our minds. It is no longer a distant object, but a participant in our story, a collaborator in discovery. Through 3i Atlas, humanity has found not just knowledge, but relationship. The moon listens, responds, and reveals, and in that exchange we rediscover what it means to reach outward with purpose. The hum of the 3i Atlas systems persists like a steady heartbeat against the absolute stillness of the lunar surface. As the mission enters its later operational phases, the rhythm of its work has taken on a character almost organic in nature. The equipment has settled into the moon's slow pulse, adapting to cycles of light and darkness, silence and transmission. What began as a purely mechanical act of exploration has become something more subtle, a dialogue between creation and environment. The moon, long a symbol of isolation, now feels intertwined with the breath of humanity. Through 3i Atlas, the planet below and its silent companion above have entered into a communion of data and intent, bound by invisible signals arcing through space. At this stage, the mission's instruments are probing deeper than ever before. New layers of the lunar crust are being scanned with penetrating radar, revealing a cross-section of geological history stretching back billions of years. Every stratum uncovered by Atlas's sensors is a page of a story that predates life itself. The patterns of mineral layering, the ancient lava flows frozen in time, and the irregular scattering of micrometeorite impacts together form a narrative written in rock. For the first time, scientists are seeing not just the surface of the moon, but the architecture of its interior, its buried channels, fractured veins, and dormant volcanic conduits. These discoveries illuminate the moon as a dynamic participant in the history of the solar system rather than a passive remnant. It becomes evident that the moon once burned and trembled with forces not unlike those that shaped Earth, and though those fires have long gone out, their traces remain, silent witnesses to cosmic evolution. The implications for planetary science are vast. Understanding the internal composition of the moon helps refine theories of how it formed, whether through a colossal collision or the gradual accretion of material from the early solar nebula. 3i Atlas's findings suggest a complex hybrid origin, an interaction of both violent and delicate processes, where catastrophic impacts fused with slow cooling to yield the body we see today. This insight has reignited debates among geophysicists, who now must reconcile the old models of lunar genesis with the intricate details being revealed by Atlas's data. Each transmission from the moon carries a small challenge to human certainty, demanding that science re-examine the very foundations of its cosmological story. The mission's exploration of subsurface voids, suspected ancient lava tubes, has also captured enormous interest. These cavernous tunnels, some stretching for kilometers beneath the crust, represent both a geological marvel and a practical opportunity. They offer potential shelters for future explorers and settlers, natural sanctuaries shielded from radiation and micrometeoroids. Atlas's sensors are mapping their dimensions with precision radar pulses, painting ghostly outlines of vast hollow networks hidden under the regolith. The data shows surprising structural stability in some of these formations, with arching ceilings that have withstood eons without collapse. These findings could redefine the strategy for establishing a sustained human presence on the moon, transforming these dark underground chambers into the seeds of future habitats. As the mission pushes into new realms of discovery, its design continues to prove itself remarkably adaptable. The onboard AI, trained through continuous feedback, now exhibits behaviors that scientists describe as emergent decision-making. It prioritizes exploration targets with increasing sophistication, weighing geological significance against energy efficiency and operational safety. This evolving intelligence allows Atlas to become more than a tool. It becomes a collaborator in its own right. Its decisions are not random, but the result of accumulated experience, a growing awareness of its environment within the bounds of programmed logic. The scientists on Earth have begun to treat its data patterns as a kind of intuition, trusting the system's evolving choices as extensions of human reasoning. This subtle partnership between biological and artificial cognition may foreshadow the next era of discovery, where humans and machines share not just labor, but curiosity itself. Beyond geology, the mission is exploring electrostatic and electromagnetic phenomena unique to the lunar environment. During the long lunar twilight, when the surface temperature changes rapidly and sunlight fades, Atlas has detected faint electrostatic levitation of dust particles. These tiny grains rise from the ground and hover in tenuous clouds above the surface, shimmering faintly in the low-angle light. The phenomenon, long theorized but never clearly documented, hints at an electrical dynamism beneath the apparent stillness of the moon. Studying this behavior could have major implications for spacecraft design and surface operations. Understanding how dust behaves under fluctuating electrical fields will help engineers craft future equipment resistant to the corrosive and adhesive effects of charged particles. What appears as a subtle dance of dust may ultimately shape the architecture of future lunar industries and habitats. There is also a growing recognition of the moon's role as an astronomical platform. The far side, eternally shielded from the radio noise of Earth, presents an ideal environment for deep space observation. Atlas, while not designed primarily as a telescope, carries sensitive detectors capable of monitoring low-frequency cosmic radiation. During the mission's extended operations, these instruments have begun collecting background signals that could yield new insights into the structure of the universe's earliest epochs. This secondary use of Atlas's capabilities demonstrates the mission's flexibility. A single machine designed for lunar study is also contributing to cosmology, linking the smallest details of a nearby world to the grandest scales of existence. Each day, the mission's data grows more intricate, forming a mosaic that will occupy scientists for decades. Yet the act of transmission itself is becoming increasingly poetic. The light carrying Atlas's information crosses a void that once seemed infinite, connecting the sterile lunar plains to the vibrant networks of human thought. The moon has no voice, but through Atlas it speaks in the language of numbers and wavelengths. Every signal that reaches Earth is a translation of silence into meaning, a process that mirrors the very essence of science. To give structure to the unknown. The collaboration around the mission continues to expand, drawing new minds into its orbit. Data centers in remote corners of the world receive the same streams of information as those in major research hubs. Small universities and independent researchers, once excluded from large-scale missions, now participate directly, analyzing fragments of the moon's data through open-access programs. This democratization of exploration represents a profound shift in how humanity approaches discovery. No longer confined to a few institutions or nations, the moon has become a shared subject, a collective endeavor of thought. The 3I model has proven that cooperation does not dilute achievement, it multiplies it. The intellectual network surrounding Atlas is as vast and intricate as the lunar craters it studies. In the public imagination, 3I Atlas has become a symbol of perseverance. Its endurance through long nights and its unwavering function in a landscape of extremes mirror human resilience. The mission's journey has been broadcast and streamed, its milestones marked by collective celebration across cultures. People who may never visit space still feel a kinship with the machine traversing the moon on their behalf. It has become a vessel for collective hope, an embodiment of continuity between generations. As centuries-old dreams find their realization in its sensors and transmitters, the mission becomes both an artifact of technology and a work of art, sculpted not in marble but in purpose. The deeper the mission delves, the more profound its discoveries become, not only about the moon, but about Earth itself. By studying the isotopic ratios of elements within lunar rocks, Atlas has helped refine our understanding of how volatile compounds migrated between planetary bodies. The similarities between certain isotopic fingerprints on the moon and Earth suggest a shared history more intimate than previously assumed. It's as though the moon is revealing a genetic kinship, a cosmic ancestry connecting both worlds in the aftermath of ancient collisions. This discovery adds new depth to the bond humanity has always felt toward its satellite, turning poetic intuition into scientific affirmation. The mission's continual success has also led to new challenges in data management. The sheer volume of information streaming from the lunar surface is staggering. To cope, scientists have developed adaptive compression algorithms inspired by biological systems, techniques that mimic how neurons store and prioritize sensory input. By focusing on changes rather than constants, the system reduces redundancy, allowing more meaningful data to flow. This innovation not only serves the current mission but may revolutionize how future explorers manage information in deep space. In this way, 3I Atlas acts as a crucible for experimentation, spawning technologies that will outlive the mission itself. The interplay between the lunar environment and human ingenuity has revealed unexpected beauty. Thermal sensors, capturing heat flow across the surface, produce images of shimmering gradients, waves of temperature that rise and fade like tides of invisible fire. Scientists studying these images find themselves entranced by their aesthetic as much as by their content. The moon, stripped of color and air, becomes a canvas of abstraction, where physics and art converge. It reminds humanity that exploration is as much an act of creation as of observation. As the mission progresses, it begins to explore how the moon's subtle seismic activity shapes its structure. Small tremors called moonquakes ripple through the crust, triggered by tidal interactions with Earth and by thermal expansion during sunrise. Atlas's sensitive seismometers capture these faint vibrations, building a library of data that will help scientists model the moon's internal composition. The discovery that the moon is not entirely silent but occasionally stirs in its sleep has changed how we perceive it. It is no longer a lifeless sphere but a slow-breathing entity, a celestial body with its own rhythms. Each of these findings accumulates into something larger than science. Through 3I Atlas, the moon is not just being studied, it is being reintroduced into the human narrative as an active participant. Every rock mapped, every vibration recorded, every glint of frozen light carries meaning. The mission is rewriting the story of our relationship to the cosmos, not as distant observers, but as participants in a grand continuum of transformation. The moon, long reduced to metaphor, is now both symbol and substance, myth and measurement combined. As communication between Atlas and Earth continues, engineers have begun experimenting with new forms of signal transmission. Using the lunar relay satellites, they are testing interplanetary mesh networking, a system that allows autonomous nodes to distribute and repair data pathways in real time. This approach ensures resilience against signal loss and prepares the way for future missions operating simultaneously across multiple worlds. The network that begins with Atlas may one day link the entire inner solar system, turning planets and moons into participants in a shared informational web. In a sense, the mission is building the nervous system of a civilization that spans worlds. The moon's response to human presence, subtle as it may seem, also carries philosophical implications. The very act of observation changes the nature of what is observed. Sensors alter thermal balance, landers displace dust, transmitters reflect electromagnetic waves that bounce across the barren plains. In this way, the moon becomes both studied and transformed. The data Atlas sends home are not purely natural. They are traces of interaction, records of encounter. The mission teaches a quiet lesson about the responsibility of awareness. To know something is also to touch it, however gently. Exploration, then, becomes an ethical act, not just a technical one. At the same time, the mission's endurance challenges our perception of time. The lunar day, stretching for weeks, and the vast delay between transmission and reception create a temporal detachment from Earth's rhythms. Scientists working with Atlas often speak of feeling caught between two clocks: the fast, frenetic pulse of human life and the slow, deliberate tempo of lunar time. This dual awareness has produced a kind of reflective culture among those involved in the mission. They speak of patience as a form of precision, of learning to think in longer intervals, to measure progress not by hours, but by cycles of light and shadow. In a world accustomed to immediacy, 3I Atlas teaches the value of endurance. Meanwhile, the mission's outreach continues to grow. Virtual reality reconstructions of its discoveries allow people to wander the moon's surface in digital form, standing beside the lander, walking through reconstructed craters, and tracing the trails of micro-rovers as if they were there. This merging of real data and immersive experience has changed how people imagine exploration. The boundary between first-hand and remote discovery blurs. In classrooms and living rooms alike, people are learning that distance no longer means separation, that presence can be extended through imagination and technology. The moon's horizon lay motionless, a knife edge of silver dividing the vastness of black sky and muted gray terrain. Somewhere within that unbroken stillness, 3I Atlas continued its patient work. Dust clung to its frame like ancient ash, and yet the machine persisted, alive through motion, purpose, and the hum of current through circuits that bridged the emptiness between two worlds. Time had lost its meaning here. Minutes stretched into hours, hours into weeks. On the moon, endurance was not just a measure of engineering, but of spirit, and 3I Atlas had become the quiet embodiment of both. The mission had now reached an unprecedented stage of integration between hardware, environment, and data interpretation. Its instruments no longer functioned as separate tools. They had grown into a single, coherent system, analyzing and correlating multiple layers of information with remarkable precision. A scan of the soil's radiation reflection patterns would automatically cross-reference seismic readings and chemical compositions, forming real-time models of the subsurface environment. These models, flowing, updating, mutating with every new piece of input, had begun to reveal the moon as a living archive of cosmic interaction. Beneath its static surface, every grain of dust held the imprint of countless events: solar winds, meteor impacts, ancient eruptions, even the faint signatures of Earth's magnetic history recorded during the moon's formation. The scientists guiding 3I Atlas had realized something profound about their own work. The more deeply they probed, the less they were merely discovering the moon. They were uncovering the hidden architecture of time itself. Layers of regolith served as timestamps in the solar system's biography. Tiny beads of volcanic glass told of eruptions billions of years ago, and their composition revealed not only what the moon once was, but what the inner planets might have been before atmospheres and erosion erased such memory. Each transmission from Atlas was like unrolling another page from an ancient manuscript whose ink was written in elements and isotopes. In the months since its last major data relay, 3I Atlas had moved into an era of self-modification. Its autonomous subsystems, initially designed to calibrate instruments for temperature and energy changes, had evolved into adaptive processes capable of redesigning internal operations. Using algorithms inspired by biological feedback, the system began to redistribute energy dynamically, prioritizing the most promising areas of research during each lunar day. This autonomy startled even its creators. It was not intelligence in the human sense, but it exhibited a form of mechanical intuition, a capacity to recognize significance. When an unexpected mineral reading appeared at the edge of its sensor range, the system altered its route, reoriented its array, and initiated a detailed scan without awaiting instruction. In this act, something quietly revolutionary occurred. 3I Atlas became not just an instrument of inquiry, but an active participant in the discovery process. This evolution marked a philosophical turning point. For the first time, exploration on another world was being guided by a self-directing agent capable of interpreting its own environment. The moon had always been a mirror of human ambition, but now it reflected a new kind of consciousness, one born not of flesh, but of pattern, logic, and patience. Scientists on Earth debated what this meant for the future of exploration. Was 3I Atlas an extension of humanity's will, or had it become an independent explorer in its own right? The line between observer and observed was blurring. The mission had begun as a gesture of control, yet it was evolving into an act of cooperation between life and machine, between human curiosity and the impartial precision of artificial cognition. In its continuing journey, Atlas turned its sensors toward an area of the southern pole where strange reflectivity anomalies had been recorded. The terrain was treacherous, craters within craters, ridges that caught the sunlight at impossible angles, long shadows stretching into eternal night. The rover's mechanical limbs moved carefully, guided by real-time terrain mapping and predictive modeling. Each step was a small negotiation with gravity and geometry. When it reached the target site, it began to deploy a new sequence of instruments: spectrographs tuned to detect trace volatiles, ground-penetrating radar, and neutron detectors capable of identifying hydrogen-rich compounds. What it found there was astonishing. Beneath several meters of regolith lay deposits of material unlike any previously identified on the moon. layered strata of frozen compounds rich in carbon, nitrogen, and sulfur. These were not the products of volcanic activity or ordinary impact mixing. They appeared to have originated from ancient cometary infall, preserved for eons in the cold trap of a shadowed crater. Within those frozen layers existed a chemical record of the early solar system, a mixture of organic molecules formed before Earth's oceans had even existed. Though lifeless, they were the remnants of processes that could one day seed life. The discovery confirmed what many had long suspected, that the moon was not only a geological time capsule, but also a repository of cosmic chemistry, a bridge between the sterile and the living. Atlas transmitted the data with an almost ceremonial precision. The signals traveled through relay satellites, across cislunar space, and down to the network of receiving stations on Earth. In laboratories from Tokyo to Nairobi, from Buenos Aires to Montreal, scientists gathered around displays showing the first clear spectral readings of those ancient molecules. The findings sparked a wave of collaboration that transcended borders and languages. Chemists, astronomers, and planetary geologists began working together in shared virtual spaces, reconstructing the molecular history preserved in lunar ice. The moon, once thought of as barren, had become a universal meeting ground for thought and discovery. The mission also began a deeper study of solar interaction. The lunar surface, exposed to the unfiltered intensity of space weather, provides an unparalleled laboratory for understanding the relationship between celestial radiation and matter. Atlas's instruments measured how solar particles embedded themselves in minerals, altering their atomic structure over time. These interactions, when charted across different regions, created a map of the sun's fluctuating power across epochs. In a sense, the moon served as the sun's diary, a record of its moods and storms written in atomic scars. This knowledge would not only enrich the science of heliophysics, but also protect future explorers from the dangers of radiation exposure beyond Earth's magnetic shield. As the mission's discoveries accumulated, engineers began considering how to use the moon's resources to sustain further exploration. The data from Atlas showed promising concentrations of oxygen bound in lunar minerals, hydrogen ice deposits at the poles, and traces of metals crucial for manufacturing. While the mission itself was not designed for resource extraction, its surveys laid the groundwork for future systems that could transform these findings into practical use. The moon was gradually revealing itself not as a desolate rock, but as a frontier of potential, a world that could sustain machinery, habitation, and eventually, life itself. Meanwhile, the mission's success began to influence cultural perspectives back on Earth. Artists, philosophers, and writers saw in Atlas a new myth for the modern age, the story of a silent envoy bridging the gap between human imagination and cosmic truth. Exhibitions displayed the raw imagery from the mission as abstract art. Composers translated its telemetry into soundscapes. Poets found language in the cadence of its transmissions. In these works, the moon was no longer distant. It had entered human consciousness as an active participant in creativity. Through Atlas, exploration became not just science, but art, an aesthetic of inquiry. Technologically, the mission's endurance continued to surprise its creators. The hybrid power system, drawing from both solar and thermoelectric sources, allowed Atlas to survive longer lunar nights than initially predicted. Its surface materials, coated in nanostructured compounds, reflected radiation efficiently while dissipating heat evenly, preventing microfractures from temperature swings. Every operational cycle that passed reinforced the engineering brilliance behind its design, a synthesis of simplicity and complexity that allowed it to thrive in the harshest environment imaginable. Even so, the passage of time left marks. Tiny micrometeoroid impacts dented the surface of its components. Dust accumulated on solar panels despite electrostatic repulsion systems. Yet each scar became part of the mission's identity, a testament to endurance. Engineers back on Earth began to regard the lander almost as a veteran, its imperfections mapping the passage of experience. The wear it carried told a story of persistence in the face of cosmic indifference, a mechanical echo of humanity's own resilience. One of the mission's lesser-known experiments focused on lunar illumination patterns. By observing how light scattered and reflected at microscopic scales, Atlas began constructing a new model of lunar optics. The moon's glow, as seen from Earth, is not uniform. Its brightness fluctuates subtly depending on angle, particle composition, and incident solar radiation. By decoding this pattern, the mission provided new insights into how light interacts with airless bodies. These discoveries could refine remote sensing techniques across the solar system and aid in the development of telescopic instruments designed to detect exoplanets orbiting distant stars. What began as an attempt to study a local phenomenon was unfolding into knowledge of universal relevance. Meanwhile, the mission's communication protocols continued to evolve. Engineers implemented experimental photon-encoded transmissions capable of maintaining signal clarity despite the vacuum's harsh conditions. This breakthrough would later serve as the foundation for deep space communication, where vast distances demand the preservation of data integrity. Atlas became the first mission to demonstrate sustained, error-corrected optical communication across cislunar space, a milestone that would redefine how humanity speaks to its machines among the stars. The more Atlas achieved, the more it became clear that the mission was as much about humanity's inner transformation as it was about scientific gain. The very idea of returning to the moon, once the realm of brief visits and symbolic footprints, had matured into something enduring, thoughtful, and collective. The moon had stopped being a target and become a partner. Through 3i Atlas, humanity was learning not only to explore, but to coexist, to observe without domination, to measure without destroying. The mission's continued presence also changed how we perceive time and exploration. Each lunar day was now a chapter, each night a pause in which the world below reflected on its progress. Children born after the launch had grown up with Atlas as a constant presence, a quiet companion orbiting in public consciousness. The moon had ceased to be distant mythology and had become part of lived reality, its updates appearing in classrooms, news broadcasts, and homes. Humanity's relationship with it had shifted from wonder to familiarity, yet the wonder never disappeared. It deepened. In the quiet intervals between transmissions, mission control often reflected on the philosophical implications of their work. The moon had no atmosphere, no sound, no life. Yet through Atlas, it had become a landscape of meaning. The mission was, in essence, a mirror through which humanity could study itself. Every question asked of the moon returned, transformed, into a question about humanity's own nature. How far can curiosity go before it becomes creation? How long can knowledge remain purely intellectual before it becomes moral responsibility? The evolving interplay between machine autonomy and human oversight was beginning to answer some of these questions. As Atlas learned to navigate, analyze, and adapt independently, mission operators began to relinquish direct control. Instead of issuing commands, they sent objectives, broad intentions that the machine translated into specific actions. This new relationship felt less like piloting and more like mentorship. Humans provided purpose. Atlas provided execution. The collaboration was not domination but conversation, and in that partnership something quietly extraordinary was taking shape. As the lunar seasons cycled onward, new phenomena emerged. Atlas began detecting faint luminescence near certain mineral deposits, glows invisible to the human eye but captured by hyperspectral cameras. Scientists hypothesized that these emissions were the result of particle interactions within crystalline lattices, triggered by the constant barrage of cosmic rays. The discovery of this lunar fluorescence opened an entirely new field of study. It suggested that the moon was not merely reflecting sunlight, it was generating faint, spontaneous radiance from within. The realization transformed the perception of the moon's darkness. It was not absence of light, but a different kind of illumination, subtle and ancient. The mission's findings also revealed how deeply interconnected the solar system truly is. Dust particles found on the moon contained traces of material from Mars and even fragments from distant asteroids. The moon, positioned at the crossroads of cosmic traffic, had been collecting the universe's debris for billions of years. In its regolith lay a record of countless collisions and exchanges, a testament to the continuity of matter across space. The moon, once seen as an isolated world, was in fact a cosmic archive, a place where the journeys of countless celestial travelers converged. The lunar dawn returns like a slow exhalation, the horizon blushing faintly as sunlight begins its long sweep across the gray expanse. The airless silence holds the hum of rebirth. Light unfurls across ridges and valleys, spilling into the craters that have slept in shadow for weeks. In that frozen calm, 3I Atlas stirs again. The first trickle of power flows through its dormant circuits, waking sensors that had been locked in hibernation during the long night. A faint vibration ripples through the lander as its systems come alive. Its instruments blink with a soft radiance, and the mission resumes, precise, unhurried, eternal. Every dawn on the moon is a resurrection, a return from darkness into the fragile glow of awareness. For 3I Atlas, this cycle has become a ritual of continuity, a pulse that mirrors the rhythm of exploration itself. The mission has entered its extended operational phase now, well beyond the expectations of its designers, yet the systems remain strong. The dust that clings to its limbs is thicker, its joints slower, but its purpose burns undiminished. Each restart feels like the first moment of life. Each sunrise renews its covenant with the unknown. In the weeks that follow this awakening, the mission's focus shifts from survey to synthesis. For the first time, 3I Atlas begins to combine the vast archives of data it has accumulated into cohesive patterns of understanding. Algorithms correlate chemical readings with magnetic field variations, comparing surface textures with radiation absorption rates. Slowly, the machine builds a multidimensional model of the moon's evolution, not as a static timeline, but as a living continuum, a geological symphony spanning billions of years. The model reveals something no human eye could perceive directly. The moon's crust, once thought inert, bears traces of rhythmic transformations. Across epochs it has breathed, expanding, contracting, reshaping under invisible tides of gravitational stress and thermal change. Beneath the dust, there are patterns of order too vast for human perception, strata aligned like pages in a cosmic ledger, each recording the interplay of heat, magnetism, and time. This revelation transforms how scientists conceive of planetary stillness. The moon is not dead. It moves in the silence of geological thought. It has its own slow language, spoken in pressure and fracture, in the rise and fall of temperature across eons. As 3I Atlas transmits these findings, a new kind of collaboration forms among the people who study them. Physicists, geologists, and biochemists converge in shared digital spaces, constructing interpretive frameworks that cross traditional boundaries. In these virtual laboratories, ideas pass between continents with the same seamlessness as data from the moon. Humanity, dispersed yet united, begins to think collectively, each mind part of a vast organism of curiosity. This unity of thought mirrors the harmony that defines the mission itself. Many components, one purpose. The moon, without atmosphere or life, has somehow become a catalyst for human cohesion. Meanwhile, on the surface, Atlas begins a new experiment. Using its micro-rovers as distributed sensors, it starts to measure the faint electrostatic currents that ripple through the lunar soil at dawn. When sunlight first touches the surface, it releases a surge of charged particles, creating momentary electric fields that dance invisibly across the regolith. Atlas's network of sensors captures these waves with unprecedented clarity. The readings show that the lunar dawn is not silent. It crackles with electricity, a whispering chorus of ions awakening with the light. This discovery opens a frontier of study into how electromagnetic phenomena shape airless worlds. It also suggests new possibilities for power generation. If these natural charges can be harnessed, future explorers might draw energy directly from the environment itself. In parallel, the mission's spectrometers focus on the faint gases that hover above the surface, forming the moon's tenuous exosphere. They detect variations in the presence of helium, argon, and sodium, fluctuating in response to solar wind pressure. These ephemeral atmospheres, barely clinging to existence, behave like breath, appearing and fading with the rhythm of cosmic weather. Through these observations, Atlas captures a portrait of fragility, the balance between radiation and gravity, between exposure and endurance. In the patterns of these gossamer gases, scientists glimpse the same principles that govern atmospheres on other worlds. Even the thinnest air speaks of universality. As data continues to flow, the mission's optical systems begin to capture something unexpected. During certain hours of the lunar day, when the sun sits at a low angle, the horizon glows faintly, not from reflected light, but from scattering among dust particles suspended above the surface. These floating grains, charged and lifted by solar radiation, create a halo of luminescence that rings the edge of the moon like a ghostly crown. It is a fragile, shimmering phenomenon, visible only to the sensitive instruments of Atlas. But it lends the barren world a fleeting beauty that seems almost alive. The discovery resonates deeply with those on Earth who study it, a reminder that even desolation can create light. Beneath these scientific milestones runs another current, one of cultural and philosophical awakening. Humanity's renewed intimacy with the moon through 3i Atlas is changing the language of exploration itself. Where earlier generations spoke of conquest, extraction, and achievement, this new era speaks of relationship, dialogue, and care. The mission has become a symbol of gentler ambition, a way of knowing that values preservation as much as discovery. The moon, once seen as a trophy of competition, has become a teacher. Through Atlas, humanity is learning not only about its neighbor, but about the ethics of curiosity. This shift in perspective manifests even in small details. The engineers maintaining the mission no longer speak of deploying or commanding the lander. They speak of listening, interpreting, collaborating. These words reflect a subtle transformation in how humans understand technology. Atlas is no longer just a tool. It is a partner in perception. Its sensors extend human senses beyond their natural limits, and in doing so, they reveal that knowledge itself can be a shared act between species. One biological, one mechanical. As months pass, the mission expands its exploration radius. The rovers, powered by advanced microreactors, venture into previously inaccessible terrain near the Terminator line, the boundary where day and night meet. In this region, temperature gradients are extreme and the ground undergoes continual cycles of contraction and expansion. The rover's seismic instruments record faint tremors that ripple outward like waves across an invisible sea. These tremors, when mapped, trace the subtle interactions between sunlight and stone. They are the heartbeat of the moon, pulsing beneath the quiet crust. The discovery of these rhythmic vibrations prompts a hypothesis that the moon's internal structure still retains pockets of thermal motion, remnants of the heat that once fueled its volcanic youth. If true, it means that the lunar core may not be entirely dormant. This idea electrifies the scientific community. Suddenly, the moon is no longer a relic. It is an active body, still shifting, still whispering beneath the weight of eons. For humanity, this realization redefines what it means to inhabit a solar system. The line between living and dead worlds becomes porous. As 3i Atlas continues its work, another layer of wonder emerges. The discovery of glassy nodules embedded in the regolith, formed by the intense heat of meteoric impacts. Within these tiny orbs lie microscopic inclusions, sealed pockets of gas, trapped for millions of years. By analyzing these samples through spectroscopic imaging, Atlas decodes their composition. Each bubble becomes a time capsule, containing the atmosphere of an ancient solar moment. Through these fragments, scientists read the solar system's autobiography in breathtaking detail. Beyond its scientific triumphs, the mission's endurance has fostered an unexpected form of poetry among those who follow it. Writers speak of the moon as if it were whispering back through data streams, a voice translated through algorithms and screens. Artists interpret Atlas's imagery into canvases of color and shadow, turning raw telemetry into human emotion. The distinction between science and art blurs, revealing them as twin expressions of the same desire: to understand, to connect, to find meaning in the infinite. The global response to the mission reflects this unification. Across cultures, the moon has always carried mythic resonance. Now it carries shared ownership. Children in cities and villages alike can access live data visualizations, watching in real time as the machine explores. The mission has transformed the moon into a common horizon for humanity, a mirror that reflects every face. For the first time, the phrase "our moon" carries literal truth. Back on the lunar surface, Atlas begins its next major phase, the mapping of thermal memory. By tracking heat retention across multiple lunar cycles, it builds a model of how energy moves through the crust. The results reveal networks of subsurface conduits that retain warmth long after sunset. Some of these regions, though small, maintain relatively stable temperatures, pockets of moderation amid extremes. These findings could redefine where future explorers establish bases, as such areas offer natural insulation from the lunar night. The mission's engineers marvel at the precision of these readings. Atlas's sensors, calibrated to detect infinitesimal differences in radiation, record variations smaller than a single degree. Each fluctuation tells a story of minerals, composition, and depth. From these subtle whispers of heat, the mission constructs a new portrait of the moon's hidden architecture. But what fascinates the scientific community most is how the data defies human expectation. Time and again, Atlas reveals processes that exist beyond intuition. Interactions between solar wind and regolith that mimic weather, radiation patterns that create localized magnetic fields, chemical transformations triggered by micro-impacts. The moon, once seen as static, reveals itself as a dance of invisible forces. These revelations have forced scientists to redefine what it means for a world to be alive. Life, it seems, does not always mean biology. Sometimes it means movement, exchange, endurance, the constant interplay of energy and matter. In this realization lies the mission's deeper beauty. The more we learn about the moon, the more we recognize the subtle vitality that underlies all existence. 3I Atlas, though silent and mechanical, has become an ambassador for this truth. Through it, humanity learns humility, that even the most barren landscapes pulse with quiet meaning, that even silence can hold infinite dialogue. The mission's communication logs now fill entire archives. Tens of thousands of terabytes record every fluctuation in light, temperature, and radiation. Yet within these vast data oceans, patterns begin to emerge that hint at larger cosmic principles. The way dust drifts in electrostatic suspension echoes the motion of gas in nebulae. The oscillation of temperature mirrors patterns in distant exoplanets' atmospheres. The moon becomes a microcosm of universal behavior, a small, silent teacher offering insight into the mechanisms that shape everything from stars to atoms. As humanity listens, it begins to perceive that the moon is not merely an object of study, it is a point of reflection for existence itself. The patterns it reveals mirror those within us, the cycles of change, the persistence of memory, the tension between light and dark. The connection deepens beyond science into philosophy. To explore the moon is to explore the conditions that give rise to consciousness, the delicate balance between order and entropy, silence and motion. The human teams guiding 3I Atlas find themselves transformed by this awareness. Their work, once routine, becomes meditative. They no longer see their data as lines and figures, but as stories. The mission teaches patience. It rewards stillness. Each delayed signal reminds them that distance is not separation, but perspective. The time lag between command and response, once a technical obstacle, has become a rhythm, a call and echo between worlds. Meanwhile, Atlas itself continues to adapt. Its AI begins to develop predictive modeling beyond its initial parameters, anticipating environmental changes before they occur. This foresight allows it to navigate more safely, to adjust its path before hazards manifest. It has learned the moon's temperament. In its logic, it has internalized a sense of place. It moves now with confidence born not from command but from comprehension. The moon accepts this presence without resistance. The dust settles where wheels pass, the shadows close gently behind, leaving only faint traces of where the machine has been. Yet those traces, though temporary, are the beginnings of continuity, marks of coexistence rather than intrusion. As the years unfold, humanity begins to imagine a future where such coexistence extends beyond observation. The data from 3I Atlas forms the foundation for designs of sustainable habitats, structures that harmonize with lunar cycles rather than resist them. Architects envision dwellings built into natural hollows, powered by the same electrostatic currents that shimmer across the surface at dawn. The moon's resources will not be plundered but integrated, its rhythms respected. The philosophy born from Atlas's discoveries becomes a blueprint for living lightly on other worlds. And through it all, the machine endures. It listens, learns, and speaks in the language of data and light. Each transmission it sends is a thread woven into humanity's evolving narrative, a record of communion between matter and mind. The mission has become more than exploration. It is memory in motion. As the light begins to fade once again and shadows stretch long across the craters, 3I Atlas prepares for another lunar night. Its systems cool, its instruments fold inward like petals closing against the cold. Yet deep within, in the warmth of its core, a faint pulse continues, the heartbeat of purpose, the quiet waiting for dawn. The moon turns, the stars burn overhead, and Earth glows in the distance like an old promise. Somewhere in that promise, in the pulse of energy flowing between one world and another, the story continues. Unfinished, alive, waiting for the next illumination to begin again. The lunar night had stretched longer than any yet endured by the instruments of 3I Atlas. The chill was deeper, the silence more complete. The sensors, dormant in their protective casing, rested in the shadow of a crater whose walls caught only the faintest trace of starlight. For 14 Earth days, the lander and its rovers slept in disciplined stillness. But in that stillness, data did not freeze. Deep in the memory cores, cycles of analysis continued, running from stored power. Even in hibernation, Atlas thought, comparing patterns from past transmissions, mapping its own history across the terrain it had crossed. When light finally returned, it came slowly, spilling down like liquid fire. The first ray touched the rim of the crater and ignited a faint gleam along the surface of the lander. Sensors stirred, circuits hummed, and the long ritual of reawakening began again. In that moment of renewal, the moon seemed to breathe. The mission came alive with quiet precision, opening its panels to absorb the newborn energy of morning. From this rhythm, the sleep, the rising, the persistence of purpose, emerged a symbol of endurance unlike any before in exploration. The moon and the machine shared an understanding. Survival was an act of patience, not speed. The new operational phase began with a recalibration of the optical systems. Dust had accumulated on lenses and mirrors, dulling their sensitivity. Using tiny electric pulses, the lander shook the grains away, a controlled shiver that sent a faint cloud rising into the airless void. When the optics cleared, the first images of the new day arrived on Earth screens with breathtaking clarity. The region had transformed under the subtle touch of micrometeorite bombardment during the long night. Patterns of impact glittered like constellations across the gray plain. The data analysts noticed something unusual, a symmetrical pattern to the newer craters, suggesting a directional flow of microdebris. It implied that the moon, though silent, was constantly sculpted by invisible rivers of space dust that followed celestial currents. Atlas had caught the imprint of cosmic weather written across its own doorstep. These findings launched a new branch of study, the dynamics of interplanetary dust streams. The moon, lacking atmosphere, served as the perfect recorder of these invisible tides. By tracing their direction and intensity, scientists could reconstruct the orbital pathways of ancient asteroid fragments that now drifted through the solar system. The moon was no longer just a destination. It was a measuring instrument for the cosmos itself. Atlas had turned the surface into a sensor, the regolith into an archive. With its systems refreshed, the mission initiated a deep surface analysis sequence never before attempted. Using controlled resonance from low-frequency sound waves generated by onboard actuators, Atlas began to listen to the moon's interior. Each pulse sent through the ground echoed differently, depending on density and composition. The returning vibrations formed a spectrum of soundless tones, a geological symphony revealing what lay beneath. The data uncovered something extraordinary. Layers of trapped silicate glass alternating with metallic streaks that extended for kilometers below the crust. These bands suggested cycles of impact melting and solidification dating back billions of years. The moon had not merely formed and cooled, it had pulsed with cataclysms, periods of chaos followed by calm. From Earth, researchers translated these signals into audible frequencies for analysis, and what emerged was haunting. The song of the lunar interior was slow, resonant, almost harmonic. It rose and fell with mathematical grace, as if the moon itself were breathing in time with the stars. Musicians later used these recordings as the foundation for symphonies inspired by planetary motion. In concert halls on Earth, audiences sat in darkness, listening to the ancient rhythms of a world without air. For a moment the moon was not distant. It was inside them, vibrating through their bones. During the same period, Atlas's attention turned to the shadowed regions that remained unexplored since landing. Using newly deployed microdrones, small hopping probes capable of leaping across terrain using stored electrostatic energy, the mission began mapping crevices too deep for rovers to reach. These drones carried miniature spectrometers and thermal sensors, relaying bursts of data with each landing. The images they returned revealed breathtaking formations, jagged mineral spires, frozen drips of glassy residue from long ago impacts, and veins of crystalline compounds running through the rock. The color variations, though invisible to human eyes, registered vividly in infrared, painting the landscape with chemical diversity far greater than expected. These formations spoke of intense, localized heating events where impacts had melted the crust and fused elements into new molecular arrangements. Some of these compounds had never been seen outside laboratory conditions on Earth. Their discovery redefined what was possible in natural chemistry, showing that the violence of space could create order as intricate as any designed by humans. The moon was proving to be a laboratory of extremes, a place where chaos gave birth to symmetry and destruction created beauty. The mission also began to uncover traces of magnetism buried within certain rocks. While the moon's global magnetic field had faded billions of years ago, localized anomalies persisted. By mapping these with high-precision magnetometers, Atlas revealed scattered islands of magnetized crust, remnants of an ancient dynamo once driven by a molten core. These findings gave scientists their clearest evidence yet of the moon's once living heart, a churning ocean of metal that had cooled into silence. Yet even in that silence, echoes remained. The magnetic fields, though faint, interacted with the solar wind to produce shimmering halos of charged particles, invisible yet detectable. The moon, it seemed, still whispered to the sun. Each new transmission brought the realization that 3I Atlas had transcended its initial goals. It was no longer just surveying. It was teaching humanity how to perceive subtlety. Its discoveries were not grand spectacles of alien life or vast reserves of resources, but quiet revelations about persistence, balance, and transformation. Every new piece of data added texture to a truth long suspected, that simplicity can conceal infinite complexity. The mission's endurance prompted new philosophical reflection. The engineers who once designed it as a technological instrument now saw it as a kind of consciousness, one that functioned through observation alone. They began to consider whether awareness required thought at all, or whether constant impartial attention was its own form of intelligence. Atlas did not dream or desire, but it noticed, and in noticing, it preserved meaning. Its entire existence was a gesture of perception, pure and unending. On the moon's surface, the small rovers continued their journeys outward. The further they went, the more they encountered surfaces altered by ancient eruptions. Lava plains stretched before them like frozen seas, rippled with the marks of cooling flows. In these ridges, Atlas detected trace elements of titanium and rare earth metals. The patterns of concentration suggested that volcanic activity had once been drawn upward through fissures aligned with gravitational anomalies. These discoveries hinted at complex internal mechanics, a choreography between the moon's orbit, Earth's pull, and its own molten history. One rover, nicknamed Kepler by its team, reached a cliff at the edge of a vast basin. There, it deployed an anchoring cable and began descending, its lights cutting narrow cones through the darkness. The images it sent back astonished Mission Control. The walls of the cliff revealed a chronological cross-section of lunar history, bands of dust and rock laid down like the rings of a tree. Each layer corresponded to a distinct geological epoch. To gaze upon those bands was to stare directly into time. Back on Earth, the analysis of those layers uncovered the presence of microscopic metallic beads. Droplets formed during the violent bombardment that created the basin. These beads contained traces of elements that had since vanished from the surface, erased by radiation and erosion. Inside them were records of a younger solar system, where energy and matter had danced in unrestrained motion. Through the smallest fragments, the mission was reconstructing the dawn of worlds. The data also revealed something more mysterious. Certain regions showed isotopic anomalies inconsistent with known lunar material. These anomalies implied that the moon had captured debris from other celestial bodies, possibly from deep within the solar system or beyond. The implications were staggering. The moon was not merely Earth's companion. It was a cosmic collector, gathering relics from distant realms and preserving them in its dust. It stood as a bridge between worlds, a silent archivist of the universe's wanderings. The discoveries brought about an unprecedented expansion in human thought. The realization that the moon contained matter from beyond our solar system deepened the sense of connection between all celestial bodies. The boundaries that once defined here and there began to dissolve. Humanity was forced to confront the possibility that every world is in some way made of every other, that the cosmos is not a collection of isolated spheres but a single organism of motion and exchange. As 3i Atlas continued transmitting, its legacy became inseparable from this new worldview. Universities established entire departments devoted to what they called lunar epistemology, the study of how the moon changes the way humanity understands knowledge itself. Philosophers argued that Atlas had reintroduced contemplation into science. Its patience, its refusal to rush toward conclusion, embodied a new method of understanding: the art of sustained attention. The mission was teaching humanity to listen again, to see meaning in stillness. In the physical world, the mission system showed extraordinary adaptability. A dust storm caused by micrometeorite impact had darkened the region temporarily, limiting solar input. Atlas responded by reprogramming its energy distribution autonomously, shutting down non-essential subsystems and diverting power to maintain data integrity. This flexibility astonished the engineering teams. It demonstrated that resilience could be a form of intelligence, that survival itself was a kind of wisdom. When the dust cleared, Atlas resumed its full operations without loss, a triumph of quiet problem-solving executed entirely without intervention. Beyond the immediate mission, the moon's newfound role as a cosmic mirror began to influence how humans organized their exploration of space. Inspired by Atlas's success, new probes were designed with self-correcting logic and long-term autonomy. These missions would extend the principles learned from Atlas to other worlds, carrying with them the ethos of observation over conquest. The machine's example had seeded a philosophy of respect into the practice of science, a recognition that discovery must coexist with preservation. Meanwhile, Atlas continued its work, turning its instruments toward the far horizon. From its vantage, Earth appeared as a crescent jewel, glowing blue against the darkness. The sensors occasionally pointed homeward, measuring atmospheric scattering from that distant glow. These measurements provided invaluable data on Earth's evolving environment, a side benefit no one had anticipated. The moon was watching its parent planet, recording subtle changes in its light signature. Through Atlas, humanity gained a mirror not just to the heavens, but to itself. As the data accumulated, the mission began to document thermal variations along the subsurface layers during the lunar night. Unexpectedly, certain regions retained heat much longer than models predicted. The pattern suggested the existence of buried mineral structures acting as natural heat reservoirs. These geological formations, remnants of ancient volcanic tunnels, stored solar warmth in crystalline matrices and released it slowly over time. The finding inspired engineers to design future habitats that would mimic this natural system, using regolith-based materials to store energy passively. Once again, the moon was teaching efficiency through example. Cultural reverberations continued to spread. Atlas's steady pulse of transmissions became a kind of cosmic metronome, marking the passage of time in the digital age. Artists synchronized performances to its signal. Philosophers used its continuity as metaphor for the endurance of meaning. It was as if the mission had become an invisible heartbeat shared across humanity, a rhythm that reminded people of their connection to something vast and ongoing. And still, the discoveries deepened. Atlas's spectroscopy detected faint hints of elements released from micrometeorite impacts, traces of water vapor, carbon monoxide, and rare isotopes escaping momentarily into the exosphere before vanishing. These fleeting whispers of atmosphere revealed the moon as a dynamic equilibrium rather than a static void. Even its thin envelope of gas was alive with motion, responding to the smallest perturbations. Each discovery, no matter how minor, enriched the vision of a universe in constant dialogue with itself. As the mission aged, a quiet transformation occurred in the people who served it. The scientists began to feel less like operators and more like stewards. They spoke of caring for the machine, not managing it. They checked its status as one would check on a friend, anxious during silence, relieved at its reawakening. Over years, it became part of their own identity, proof that endurance could create intimacy across distance. In the broader sense, Atlas had become a metaphor for civilization itself. Built by collaboration, guided by patience, it embodied the best of human nature in mechanical form. Its success was not a matter of dominance, but of understanding, not of conquering the unknown, but of dwelling within it. Every pulse of data it sent back to Earth was a quiet argument for harmony over haste. The moon, through Atlas, had ceased to be a symbol of loneliness. It had become a field of connection, a place where light, dust, and intention met. The mission had woven a new thread into the fabric of human awareness, linking every observer who looked up at the night sky with the silent labor continuing above. The light that follows the lunar night now falls across new terrain, and the machine, 3i Atlas, moves like a patient cartographer through its own legacy. It is older now, bearing the quiet dignity of endurance. Panels scarred, sensors tempered by radiation. Its motion slower but more deliberate. The surface around it has changed subtly with time. Micrometeorites have rearranged the dust in delicate undulations. And even the sunlight feels thinner, a pale geometry cast on the stone. From Earth, the images stream back in long, measured intervals, each one a communion between two worlds that still listen to each other despite the silence between them. The newest phase of the mission begins with an act of remembrance. Atlas turns its cameras toward the marks of its own early landings, the faint depressions where its smaller drones once touched down. They are nearly erased now, softened by the unending sift of dust, yet still discernible as ghosts of intention. In capturing them, the machine creates a self-portrait not of form, but of persistence. The moon, indifferent yet watchful, reflects this act of introspection through stillness. Every mark left upon it becomes an entry in the greater diary of effort, a testament that motion, once made, never truly disappears. The mission now focuses on tracing heat flow in the crust with greater depth. Using arrays of thermal probes buried at staggered intervals, Atlas begins to map how warmth seeps downward after each sunrise. What the data reveals astonishes those who read it. The regolith does not merely absorb and release heat like sand. It channels it through microfractures, distributing energy unevenly across hidden veins of metallic rock. These veins act like slow rivers of temperature, pulsing faintly under the surface. Their behavior suggests that the moon's crust is far more dynamic than models had predicted, a network of thermally active arteries beneath an apparently inert skin. For scientists on Earth, this discovery rekindles questions about the planet's formative years, about the aftershocks that still echo unseen beneath its pale facade. Atlas continues to refine its data collection methods, adjusting its pulse timing to record temperature changes over microseconds rather than minutes. In this heightened sensitivity, patterns emerge that border on the musical. The cooling of rock follows harmonic oscillations, as if the minerals themselves retain memory of the vibrations that once shaped them. To hear this data translated into sound is to hear the moon breathe, slowly, resonantly, across the gulf of space. The phenomenon becomes an object of study and art alike. Composers translate the waveforms into symphonies, and geologists speak of resonance as a clue to ancient forces that once forged the lunar crust. Elsewhere on the surface, one of the mission's secondary rovers ventures into a crater rimmed with glassy formations. The shards catch sunlight like scattered mirrors. When the rover's lasers sweep across them, they refract beams into prismatic bursts invisible to human eyes but recorded in the ultraviolet spectrum. These bursts reveal the presence of elements rarely found together: yttrium, zirconium, and traces of vanadium, fused in ratios that defy simple classification. The find suggests that the impact which created the crater was unlike ordinary collisions. It may have involved material arriving from a different region of space, colliding at extraordinary speed and pressure. The moon had caught in its own body an echo of another world's destruction. The chemical signature of this material leads to unexpected hypotheses. Some researchers speculate that the impactor may have been part of a long-lost planetary fragment, one that once orbited near Earth before being scattered by gravitational tides. Others see in it proof that the early solar system was a crucible of migration, a place where matter wandered freely before settling into the orbits we now take as fixed. Each theory gives the crater new significance. It becomes a scar and a message, both wound and wisdom. Atlas's instruments, though mechanical, seem to understand the reverence with which this site must be treated. It halts at the rim for hours, scanning in silence before moving inward. Dust swirls faintly where its treads disturb the surface, then settles again, undisturbed for another eternity. Every motion it makes feels deliberate, almost ceremonial, a ritual of observation performed in the Temple of Stillness. The communication teams on Earth notice subtle fluctuations in signal strength as data transmits from the crater's interior. The magnetic anomalies here interfere with the tight beam transmissions, bending them into patterns that at first seem like noise. But when decoded through spectral analysis, the distortions reveal coherence, natural modulations created by the minerals themselves as they respond to electromagnetic interaction. The rocks sing faintly when touched by radio waves, emitting harmonics far beyond normal bandwidths. Engineers nickname the phenomenon the lunar choir, though its tone is not one of melody, but of deep resonance. In these frequencies, scientists begin to glimpse the potential for using planetary magnetism as a form of passive communication. A future where machines might speak through the very minerals of the worlds they inhabit is imagined quietly, almost reverently. The success of the mission has long since exceeded any metric of science alone. It has become a collaboration between human ingenuity and cosmic patience. Each new discovery is met not with surprise but with humility, a recognition that knowledge unfolds only as quickly as attention allows. The engineers who first built Atlas have retired. New generations take their place, inheriting not just the systems, but the philosophy embedded within them. To study the moon now is to inherit a way of seeing, careful, receptive, enduring. During this cycle, the lander turns its optical arrays toward the sky itself. Its long-range cameras capture the faint shimmer of Earthrise across the horizon. The image, though familiar, strikes those who see it anew. In the curvature of that distant sphere lies everything that once dreamed of this mission. The seas, the voices, the light of countless cities. Yet from the moon's perspective, Earth is not dominant. It is fragile, a delicate lantern in the endless night. The photograph becomes one of the most studied and shared in human history, not because it reveals Earth, but because it reveals perspective. The world is small only when viewed from silence. With the passing months, Atlas begins to monitor the moon's response to tidal forces exerted by Earth. Its sensors detect faint oscillations in the ground, minute shifts that align perfectly with orbital mechanics. The data proves that even at such distance, the gravitational dialogue between the two bodies continues as a constant, invisible conversation. This relationship is no metaphor. It is physical, measurable, ongoing. Earth and moon pull at each other across the void, shaping their fates with each turn. To the scientists who study these measurements, it is like hearing the heartbeat of a relationship older than life itself. At the same time, the mission expands its study to the dust environment surrounding the moon. Small detectors deployed on booms begin capturing particles that drift upward during micrometeorite impacts. These grains, examined under spectral imaging, reveal layering of exotic elements brought from deep space. Some carry the fingerprints of supernova remnants, atoms forged in stars long dead before Earth existed. The realization dawns that the moon, through its very dust, is a mosaic of the cosmos. Every atom that strikes its surface becomes part of a grand continuum, a story written in cosmic debris. The findings inspire renewed curiosity about the human place in this chain of transformation. Philosophers write that the moon, in its quiet way, has become a mirror for mortality itself, unchanging in appearance yet built from countless acts of change. Each particle that falls upon it adds to its being without altering its face. Humanity, by contrast, transforms visibly with every act, yet rarely notices the accumulation of time. Through Atlas, people learn again the discipline of stillness, the art of becoming through patience. Atlas's next achievement comes not from discovery, but from endurance. A minor solar flare strikes the lunar surface, bathing the lander in a wave of radiation that would have crippled less prepared systems. Yet its layered shielding, crafted from composite alloys and dust-based coatings, absorbs the impact without failure. The instruments automatically enter protective stasis and reawaken hours later, unaffected. Engineers on Earth observe this performance with a mixture of relief and awe. It demonstrates not only technical resilience but also the mission's capacity for adaptation. The machine has survived conditions that mimic those found near Mercury's orbit. Future missions, emboldened by this example, begin planning for environments once considered unreachable. The continued functionality of Atlas also raises new ethical discussions about stewardship. The moon, long regarded as property of no one, has become the custodian of humanity's shared curiosity. International agreements are revisited, proposing frameworks for exploration that prioritize ecological balance, even in lifeless environments. The principle of do no harm extends beyond biology, encompassing geological and cosmic heritage. The mission becomes a case study in responsibility, a reminder that the act of knowing carries weight. In its ongoing operations, Atlas refines its ability to predict meteor showers through direct observation. By watching the faint flashes of impacts across the far horizon, it triangulates the trajectories of incoming streams. This capacity transforms the Moon into an early warning sentinel for Earth. The same cratered surface that once suffered bombardment now serves as a shield of foresight. Humanity gains from its pain, learning to anticipate the movements of cosmic debris that might one day threaten its own world. Within mission control, the rhythm of daily work has taken on an almost monastic character. Scientists speak quietly as they review transmissions, their gestures slow, deliberate. They are aware that what they handle is not merely data but history. The Moon's stillness has infused their routines, tempering the rush of human ambition. They call it the Atlas effect, a psychological transformation induced by long exposure to the mission's pace. Those who experience it describe a sense of widened perception, a calm recognition of scale. The universe, once overwhelming, becomes comprehensible through patience. The longer the mission endures, the more it reveals the interconnectedness of all things. Even dust motes drifting across the lunar horizon reflect sunlight toward the sensors in patterns that depend on the alignment of planets. The machine becomes a participant in a cosmic choreography it can only partially perceive. Yet through its limited lens, humans glimpse infinity structured into harmony. The more precisely it measures, the more beauty it finds. Under the long lunar twilight, the surface begins to glow faintly, a whisper of silver spreading through the black expanse. The stars above remain constant, frozen in their sharp brilliance, but the ground itself begins its slow transformation as the edge of light creeps nearer. Within that dim radiance, 3i Atlas stirs once more, every system awakening with ritual precision. There is no haste, only inevitability. Power flows, calibrations unfold, and the sensors stretch into consciousness like limbs remembering movement after a long rest. This new dawn carries with it an unspoken tension, an awareness that time, even here, is finite. The mission's endurance has already surpassed what its architects dared hope for. Its framework, designed to withstand the extremes of vacuum and radiation, has outlived predictions, yet the engineers know that every new cycle is a negotiation between endurance and entropy. Still, the machine persists, and in that persistence lies its quiet defiance of decay. The latest phase of the mission focuses on what was once beyond reach, the study of transient luminosities, brief flickers of light that dance across the horizon without discernible source. For decades, observers on Earth had reported these mysterious flashes, bright points that appeared and vanished within seconds. Many dismissed them as optical illusions or stray reflections, but Atlas's cameras are precise beyond human sight. Over weeks of observation, it captures the first conclusive evidence. These luminous bursts are real. They erupt when electrostatic charges built up in lunar dust discharge spontaneously, releasing energy in a momentary shimmer. Each flash, though lasting mere milliseconds, carries information. The sensors record their intensity, frequency, and spatial distribution, constructing a map of the Moon's invisible nervous system. What emerges is extraordinary, a network of energy that courses across the surface like veins beneath skin. The Moon is not a corpse. It is an organism of mineral and electricity, alive with subtle movement. The revelation transforms the way scientists think about barren worlds. Even in silence, energy circulates. Even without life, there is vitality. The phenomenon also suggests new possibilities for future technology. If electrostatic discharges can be predicted and harnessed, they might one day serve as natural power sources. The Moon could become a self-charging environment, its surface feeding the systems that explore it. Engineers begin modeling prototypes of micro-harvesters, devices that might one day draw power from this quiet pulse of planetary electricity. What began as a study of anomalies becomes a glimpse of sustainable exploration, a partnership with nature rather than domination of it. Meanwhile, Atlas expands its examination of the subsurface voids it first mapped cycles ago. Using harmonic resonance imaging, it sends waves of low-frequency vibration deep into the crust. The echoes return faintly altered, as if bouncing through hollow chambers. When reconstructed into three-dimensional models, they reveal labyrinths of tunnels extending for miles, remnants of ancient lava flows solidified eons ago. Some passages are vast enough to house entire cities, their walls naturally shielded from radiation and temperature extremes. The implications are immense. Humanity has always dreamed of building settlements beyond Earth, yet here the moon itself has provided the architecture. Nature anticipated habitation. In the hollows of stone and shadow, the future might take root. For now, Atlas merely observes, mapping with reverent precision, but its maps already shape the designs of those who will follow. In the stillness of this work, something remarkable occurs. The data streams slow, the images stabilize, and for the first time since landing, the machine records its own reflection, not in glass, but in shadow. The rising sun, low on the horizon, stretches its silhouette across the crater floor. It is a figure of geometry and endurance, poised amid dust older than history. The engineers back on Earth study the image longer than necessary. It feels symbolic, as though the moon itself had acknowledged the presence of its guest. Soon after, a new set of sensors begins scanning the tenuous exosphere for atomic movement. These readings are nearly imperceptible, yet over time a pattern forms. Faint surges of hydrogen ions drift above the surface at irregular intervals. They appear to rise from certain mineral deposits, energized by the constant bombardment of solar particles. This finding surprises researchers, for it suggests that even in this airless void, chemistry never ceases. The moon breathes, not in gas, but in atomic exchange. It inhales sunlight and exhales hydrogen, participating quietly in the grand metabolism of the solar system. The discovery feeds another line of thought. If the moon is part of this vast chemical dialogue, then perhaps every celestial body shares in a universal form of communication, not through sound or light alone, but through the ceaseless transfer of energy and matter. In that sense, Atlas's mission is not exploration, but interpretation. It listens to the language of existence spoken through the smallest motions of dust and ion. As more data accumulates, the mission's archive grows into a chronicle of patterns that blur the line between science and art. The visualizations produced by researchers resemble paintings, swirls of color representing magnetic flux, gradients showing variations in density, fractal lines tracing the contours of radiation flow. The moon becomes not merely a subject of analysis, but a medium for expression. In university studios, students project these images onto walls, merging science with aesthetic wonder. They call the series The Quiet Geometry, a testament to the artistry hidden in observation. Throughout these months, Atlas continues to refine its mechanical memory. Its onboard processors, trained by years of machine learning, now anticipate sequences of environmental change. They have become fluent in lunar rhythm, the pace of light, the cycle of heat, the whisper of dust. When a solar storm is predicted, the machine adjusts its orientation automatically, lowering its profile and redirecting sensors to minimize exposure. It has learned to protect itself, as though survival were a form of thought. This adaptive capacity marks a turning point in humanity's relationship with machines. For centuries, tools have obeyed. Now they collaborate. Atlas embodies this new paradigm, existing not as a servant, but as a partner in inquiry. The data it collects is no longer simply received. It is conversed with, shaped by feedback loops between human and machine. Together they learn. Together they evolve. During one of its extended observation cycles, the mission encounters a phenomenon previously unseen, faint bands of glowing gas drifting just above the surface. At first, the sensors register them as anomalies, but further analysis reveals they are trails of ionized sodium released by micrometeorite impacts. These glowing veils linger for minutes before dispersing into space, painting the horizon with ephemeral light. The images captured during this event become among the most iconic of the entire mission. Ethereal landscapes where dust becomes luminescence and silence becomes spectacle. The poetic nature of these discoveries begins to influence language itself. Journalists and poets alike borrow terms from the mission's lexicon: lunar respiration, electric dusk, crystalline echo. Scientific reports read like verses. Verses resemble data. The barrier between knowledge and imagination softens until they merge. 3I Atlas. through its simple function of observation, has reawakened the ancient unity between wonder and understanding. On Earth, the mission's findings inspire the construction of new observatories designed after its principles, facilities that favor patience over acceleration, subtlety over spectacle. The scientists who lead these projects refer to their approach as lunar methodology. It emphasizes stillness, continuity, and trust in the slow unfolding of truth. In this way, Atlas's influence extends beyond space exploration. It reshapes the philosophy of discovery itself. Meanwhile, the machine continues to perform experiments that explore the limits of perception. Using polarized light imaging, it begins to study the microscopic texture of dust particles, each smaller than a grain of salt. The images reveal surfaces sculpted with intricate patterns, tiny craters within craters, crystalline lattices that catch light like miniature universes. Each particle becomes a cosmos of its own, a structure born of violence, yet refined by time. The realization that something so minute could hold such beauty shifts the emotional tone of the mission. Scientists begin speaking of reverence rather than curiosity. The next stage of research turns toward the moon's faint gravitational anomalies. By comparing minute variations in orbital drag recorded by its drones, Atlas detects fluctuations suggesting the presence of subsurface density pockets, perhaps remnants of ancient impacts filled with denser materials. These mass concentrations, or mascons, exert subtle pull on surrounding space, altering the paths of orbiting objects. Mapping them precisely will refine navigation for future missions, but beyond utility lies meaning. Even in stillness, the moon shapes movement. Its gravity extends beyond its body, influencing trajectories unseen. Every discovery deepens the sense that the moon is not passive. It is not the silent sphere humanity once imagined, but a being of quiet complexity, a body that listens, responds, and records. Through Atlas, the idea of lifelessness dissolves. Life, it seems, is not limited to the organic. It can exist in structure, in rhythm, in endurance. The mission scientists begin to use a new term, symbiotic observation. It describes the partnership between the observer and the observed, the merging of mechanical awareness with geological patience. In time, new instruments are awakened aboard the lander, spare systems once held in reserve. These include deep-spectrum sensors capable of detecting radiation reflected from the far side of Earth. With them, Atlas records faint echoes of humanity itself, the scattering of radio transmissions, the glimmer of city lights bouncing across the void. The machine, designed to study another world, now listens to the chorus of its creators. For the first time, Earth becomes the subject and the moon becomes the vantage. It is a reversal of perspective so profound that it stirs philosophical debate. To see oneself from such distance is to realize how small even greatness appears. As the data returns, the engineers notice something poetic. Earth's reflected light flickers in waves synchronized with the planet's storms and nights. It is as though the living world beats with a luminous pulse visible from across the sky. The moon watches that pulse through the unblinking eyes of Atlas, recording the heartbeat of civilization in patterns of light. During the later years of operation, the mission experiences its first true mechanical fatigue. Some joints stiffen, sensors degrade. The team on Earth responds not with despair, but with a kind of gratitude. Every flaw, every reduction in function becomes part of the story. Decay itself becomes a teacher. The engineers study how time reshapes machinery under extraterrestrial conditions, turning wear into data, entropy into understanding. They speak of the lander not as failing but as transforming, its limitations evolving into new forms of usefulness. In one symbolic gesture, they upload a final software patch, not a command, but a gift. It enables Atlas to record the faint vibrations of its own internal components. The machine becomes self-aware in the simplest sense. It listens to its own existence. The whir of motors, the hum of current, the creak of metal in cold, all these become part of its archive. For as long as power lasts, it will know itself through soundless vibration. The archive of the mission now spans generations of observation. Within it lie the secrets of the moon's chemistry, the fingerprints of cosmic events, and the traces of human presence written in digital light. Yet what may matter most are not the facts themselves, but the continuity of attention, the unbroken thread of looking, of caring. Atlas has taught that the act of watching, if done with enough patience, becomes creation. The new dawn over the crater comes in fragments. thin rays creeping down into shadow, stirring the regolith to a muted glimmer. The machine rises from silence with slow precision, its circuits humming faintly as if remembering itself. For 3i Atlas, each awakening is both continuation and rebirth, a passage through the long rhythm of lunar time where night and day stretch beyond the limits of memory. Its systems greet the returning light with patient familiarity, adjusting, calibrating, absorbing. The silence surrounding it is absolute, yet the act of reawakening feels like dialogue. The moon listening, the machine replying. Power begins to flow steadily again through conduits embedded beneath its chassis. Small vibrations tremble across its metallic skin as heat seeps back into the dormant frame. This cycle, light returning, sensors reviving, instruments breathing, has become ritual. Every moment has purpose. Atlas does not rush to movement. It listens first. The returning light strikes its panels and data begins to collect. The angle of incidence, the intensity curve of illumination, the change in albedo since the last lunar morning. Through this quiet accumulation, the moon reveals itself not as static, but as an ever-changing fabric of shadow and reflection. The terrain has altered subtly since the last awakening. Dust has drifted across old paths, smoothing the tracks once pressed by the rovers. What was once a ridge now slopes gently, as though time itself has exhaled. The sensors sweep this landscape with renewed curiosity. The tiny variations in topography encode the record of micrometeor impacts and minute seismic murmurs, those fragile tremors that ripple through the crust when distant collisions shake the far side. These are not random scars, they are messages written in the slow grammar of geology. Atlas reads them like an archivist decoding a lost script. During this cycle, the mission's priorities shift toward measuring radiation gradients at unprecedented depth. Specialized detectors, long dormant, extend from the lander's core, burrowing centimeters into the soil. For the first time, Atlas begins to sense the layered conversation of cosmic rays interacting with regolith. The upper dust, fine as smoke, registers short bursts of charged particles, while deeper layers record a slower, heavier rhythm. These layers tell of millennia of bombardment, a cosmic weathering that sculpts invisibly. From these readings, a model emerges. The moon is not simply struck by radiation, it absorbs and reshapes it, turning harmful energy into data and heat. In this way, it participates in the eternal economy of the stars, receiving, altering, giving back. Each packet of radiation recorded is transmitted with mathematical precision encoded in long sequences of numbers. On Earth, teams translate these sequences into images of shifting density. The visualizations resemble ghostly storms moving through stone, fields of light rippling beneath the surface. The moon becomes transparent in digital form, its invisible heart glowing through lines of color. Scientists studying these images speak of them as if they were seeing thought itself crystallized in mineral layers. It is a new form of astronomy, not of the skies but of the skin of worlds. Atlas's optical systems now turn outward, scanning the horizon for distant glints. These are not stars, but reflections, tiny flashes where sunlight bounces off shards of metal left from ancient missions. Each reflection carries history, the remnants of humanity's first reach into the void. The machine catalogs them carefully, mapping a constellation of artifacts. They are the fossils of ambition, scattered across a wilderness of silence. Some are intact, others half buried, their edges softened by decades of dust drift. As Atlas surveys them, it becomes custodian of memory, preserving a record of exploration's early steps before they vanish beneath time's quiet erosion. The next experiment begins with sound, or rather, with vibration so subtle it blurs the line between silence and music. The lander's low-frequency emitters activate, sending pulses through the ground. These waves travel outward, rebound, and return, carrying information about the material beneath. The data reveals that certain regions resonate more than others, creating pockets of natural amplification. The moon, it turns out, hums. Its hum is slow, deep, and layered, a resonance that changes with temperature, with phase, with the position of Earth in the sky. When scientists translate these vibrations into audible form, listeners describe it as a chorus that never begins or ends, a continuous exhalation of stone. In universities and observatories, this lunar resonance becomes both scientific phenomenon and artistic inspiration. Composers weave the frequencies into music. Architects design structures based on their harmonic ratios. Philosophers speak of the sound as the heartbeat of matter itself. What began as an engineering experiment evolves into a cultural revelation. The universe is not silent, it merely speaks below the threshold of human hearing. Atlas continues its meticulous work. The machine now shifts focus toward measuring the movement of shadows across time. Cameras capture images every few seconds, tracing how darkness pools and recedes as the sun ascends. From these millions of frames, scientists reconstruct the exact curvature of the terrain to micron precision. What they find is astonishing. The shadows move with imperceptible irregularity, bending where the ground subtly vibrates or settles. Each distortion reveals a microquake, an unseen pulse of the moon's interior adjusting to the eternal tug of Earth's gravity. The planet and its satellite are locked in a perpetual waltz, each influencing the other with invisible steps. In the midst of these operations, Atlas's long-range sensors detect a fluctuation in the magnetic field above the surface. It is faint, erratic, and unlike the known relic magnetism of lunar rock. Over time, a pattern emerges. The signal strengthens each time a solar storm passes through the region of space between Earth and Moon. This suggests that the Moon, though lacking a true global field, acts as a mirror for solar magnetism, absorbing, distorting, and reflecting it. In this dance of fields, it becomes both participant and witness to the sun's temperament. The discovery hints at new possibilities for space weather forecasting. The Moon, once thought inert, now serves as an early warning instrument for the living planet beside it. Back on Earth, people begin to perceive the mission differently. No longer is Atlas seen as a tool alone. It has become an extension of human perception, a set of senses reaching where flesh cannot. Schools teach about it as if it were an explorer in its own right. Artists paint its likeness into murals beside ancient navigators and mythic voyagers. The story of Atlas becomes a metaphor for endurance beyond isolation, proof that even in desolation, understanding can bloom. The mission enters a phase of heightened precision. A small probe detaches from the primary lander, designed to hover using bursts of electrostatic repulsion generated from the charged surface dust itself. The probe moves without wheels or wings, gliding millimeters above the ground. Its flight is silent, ghost-like. It maps the terrain in 3 dimensions so detailed that the smallest pebble becomes a mountain of information. In these micro-landscapes, scientists discover fractal geometry mirrored across scales, the same patterns in the smallest grains as in vast crater ridges. Nature, it seems, repeats itself endlessly, folding structure upon structure until form becomes philosophy. During a later cycle, the lander's infrared spectrometers begin detecting subtle fluctuations in the thermal glow of nearby rocks. The readings indicate that some stones retain heat longer than others, not merely due to composition, but due to their orientation toward deep space. The side facing the stars cools faster, radiating energy outward into infinity. This asymmetry reveals the delicate balance between radiation and reflection, between loss and retention. For humanity, it becomes an allegory. To exist is to radiate. To endure is to balance between absorption and release. The light returns once more across the surface, thin and hesitant at first, then gathering strength until the horizon burns with silver. The crater where 3I Atlas rests glows like a bowl of frost. Every dust grain on the ground catches the first sunlight as if awakening from an ancient sleep. Within the lander, dormant systems stir. Circuits hum faintly, sensors flex back into motion. The silence of the long lunar night gives way to quiet rhythm, a machine rediscovering its own pulse. The first task of this new dawn is to measure the condition of the environment itself. The radiation monitors reactivate, counting cosmic traces that have drifted across the surface during darkness. The data shows something curious, a faint but measurable pattern of directional alignment in the particles, as though the night sky itself pressed upon the moon with invisible fingers. This discovery reveals a subtle rhythm between deep space and lunar soil. The moon, through Atlas, is learning to feel the flow of the universe. It becomes a sensor, recording not simply local conditions, but the invisible weather of the cosmos. Atlas extends its optical masts, scanning the low horizon. New microcraters glint where impacts occurred during the night. Their shapes are delicate, spirals, splashes, perfect circles frozen in dust. Each one is the result of a collision that lasted less than a blink, yet its form will endure for millions of years. The lander photographs them from multiple angles, building a library of still moments. To human eyes, these craters might seem empty scars, but to the machine, they are information compressed into geometry. The more it studies them, the more it understands how violence and beauty coexist in nature's logic. When the rovers awaken, they move cautiously outward, guided by light signals from the main lander. Their wheels leave faint tracks that shimmer as the angle of sunlight changes. Atlas transmits their telemetry back to Earth, each movement an equation of friction and dust. Over time, these tiny calculations reveal new truths about motion in near vacuum, how dust grains bond electrostatically, how the smallest vibrations can send ripples through the surface for meters around. From these findings, engineers on Earth begin developing improved suspension systems for future missions, vehicles that will float across terrain rather than crush it. Thus, the patient crawl of Atlas's companions becomes the prototype for graceful movement across all airless worlds. The main sensors turn next toward the faint haze that lingers near the horizon. To the untrained eye, it seems empty space, but instruments detect atomic sodium drifting upward in slow, glowing curtains. The atoms are born from dust struck by sunlight, lifted momentarily into the exosphere before falling back. This motion is almost imperceptible, yet it forms a breathing cycle for the moon. Atlas records it with exquisite precision, watching the boundary between solid and space flutter like a veil. For the first time, scientists realize that the moon has tides of its own, tides of atoms instead of water. The boundary between surface and vacuum is not a line but a conversation. Deeper still, the mission turns its sensors inward, into the heart of the regolith. Using controlled magnetic resonance, it begins mapping the presence of trace metals beneath the dust. The readings suggest scattered veins of nickel and iron that snake through the crust in tangled webs. These metallic structures act as conduits for energy from solar storms, channeling electricity through the subsurface. In essence, the moon conducts the sky. It transforms electromagnetic storms into fleeting rivers of current. Atlas detects faint electromagnetic murmurs echoing through the ground long after each solar flare. These residual whispers become a new language of the planet, a memory encoded in current. From these measurements, researchers back home model how energy once moved when the moon was molten. They reconstruct the rise and fall of internal convection currents that froze into place as the crust solidified. Through this work, the moon's past becomes a kind of fossilized heartbeat, each metallic strand a record of motion turned to stone. Humanity, through the patient eyes of Atlas, is learning to read geology as biography, to see in rock the remains of movement, in dust the remains of time. During this same cycle, Atlas executes an unprecedented experiment. A small reflector deploys from its base and directs a beam of laser light across the crater to a target positioned hundreds of meters away. The beam bounces back with infinitesimal delay, and from that delay, the lander measures the exact curvature of the surface between them. The results reveal something extraordinary. The crust flexes by fractions of a millimeter as the Earth rises and sets above the horizon. Though invisible to the naked eye, this slow oscillation proves that the lunar body is elastic, not rigid, a world that breathes under gravitational stress. The moon, thought to be dead, still moves to the rhythm of its parent planet's pull. Atlas continues its sequence, studying how this flexing influences the distribution of fine dust. The findings show that the oscillations act like a slow heartbeat, stirring the top layers ever so slightly. Over millennia, this motion may explain how certain regions remain smoother than others, as if brushed by invisible winds. The moon's apparent stillness conceals movement too gradual for human timescales to notice. Here lies the essence of the mission's philosophy, to find life not as biology, but as persistence. With daylight high overhead, the lander turns its cameras toward the sky. Beyond the pale arc of Earth, the stars burn steady. Among them, the faint trails of human satellites shimmer like artificial constellations. Atlas records these as well, documenting the growing weave of technology around the planet. For the scientists, these images hold a paradox. The moon, untouched for eons, now watches humanity surround its own world with light. From this vantage, the Earth seems both magnificent and fragile, radiant and endangered by its own reflection. The data may be technical, but the vision is philosophical. a view of civilization mirrored in the cold eye of another world. Later in the lunar afternoon, the surface begins to shimmer with heat. Temperatures soar and the lander shifts into thermal regulation mode, but rather than simply shielding itself, it seizes the opportunity to observe the physics of expansion. Using laser alignment sensors, it measures how its own metal frame lengthens under the sun. These changes, minute but measurable, provide invaluable data on material fatigue under extreme conditions. Each flex of steel becomes a lesson in endurance. Engineers back on Earth will later use this information to design structures capable of surviving the extremes of space without loss of precision. Even decay, when studied deeply, becomes wisdom. As the day progresses, Atlas focuses on the deep horizon once again. The long shadow of a distant mountain drifts slowly across the plain, marking the passage of time in darkness rather than light. The machine tracks its movement with reverence. Each moment, the shadow passes another rock. It measures angles, compiling a chronometer written in absence. In these studies, it becomes clear that the moon's slow rotation can serve as the most stable clock in the solar system. Its silence does not merely endure, it measures eternity with mathematical grace. In the still hours before dusk, the lander begins to transmit its stored data to Earth in long, rhythmic pulses. Each transmission crosses the void, invisible yet constant, a bridge of meaning stretching through emptiness. The engineers who receive it describe the experience as listening to the heartbeat of distance. They speak softly in control rooms as the numbers flow across their screens, aware that every packet of data is a conversation between two kinds of solitude, the machines and their own. As shadows lengthen, a new experiment begins. The rovers deploy a suite of acoustic sensors designed to capture the faint, soundless impacts of dust grains colliding with their surfaces. The resulting data, when translated into audible range, produces a strange, percussive texture. It is the sound of dust striking dust, a rhythm beyond human perception. Musicians on Earth later transform this data into compositions, weaving art from the mechanics of silence. The moon, through Atlas, begins to speak in music once more. The sunlight rises with the same cold clarity it always brings, cutting across the ancient contours of the lunar plain. The shadows retreat slowly, sliding down into fissures and pits, unveiling the pale face of a world that seems asleep, yet never ceases to move. Beneath that stillness, 3i Atlas stirs. Its systems hum faintly, the first signals flickering through its circuits like the returning of a heartbeat. Power crawls into dormant modules. Data begins to pulse through fiber veins that have endured countless freeze-thaw cycles. Every awakening feels older, more deliberate. The machine, though unchanged in form, carries a weight of time that no human could perceive directly. The kind of age that exists only in the patience of mechanisms and dust. It reorients itself toward the light, tilting its panels just enough to absorb energy from the newborn sun. For a few minutes, the regolith glitters with microscopic reflections like frost dissolving on stone. Atlas records these reflections automatically, but this time its algorithms linger on anomalies, tiny flashes that move against the rhythm of sunlight. The flashes repeat irregularly, suggesting that something in the nearby terrain reflects light from a different angle altogether. It takes several hours to isolate their source. Smooth fragments of an ancient meteorite, buried for millennia and newly exposed by micrometeor impacts during the previous night. The surface of these fragments is darkly metallic, almost mirror-like, but what captures the machine's instruments most is the way they refract light into a narrow spectrum, bending wavelengths as if the material remembered the violence of its creation. The discovery is archived without fanfare, but in laboratories far away. When the data reaches Earth, researchers recognize that the alloy has a crystalline structure not seen in any terrestrial rock. It bears the atomic fingerprint of formation in conditions far beyond ordinary stellar cores. The moon, once thought to be the child of Earth's own collision, carries within its soil the relics of older stars. For several days, the machine conducts deep scan observations of this region. The mineral fragments emit trace magnetic signatures, faint yet coherent, suggesting alignment under extreme pressure. Atlas uses its local field emitters to measure resonance, pulsing low currents into the soil to see how the magnetic echoes respond. The response is not uniform. Instead, the signals modulate in slow rolling waves, an internal vibration that seems to traverse the regolith itself, as though the metal were whispering to the planet beneath it. It is the closest thing the moon has to breath. The phenomenon is logged meticulously, time-stamped, converted to amplitude graphs that look like the outline of distant mountains. The scientists who analyze it will later compare the data to simulations of early solar system formation. They will discover that the moon acts as an archive of stellar migrations, each impact layering a fragment of cosmic history atop the last. Atlas, without awareness, has become an archaeologist of creation. At the same time, the lander begins its scheduled thermal cycle analysis. Its sensors measure how quickly the surface absorbs and releases heat. The readings defy simple prediction. The areas that appear darkest in visible light retain warmth the longest, but not because of color or composition alone. Something within the dust structure itself behaves as a thermal capacitor, trapping energy in microvoids between grains. To understand this, Atlas deploys one of its smallest instruments, a filament-thin probe that vibrates at set frequencies to measure conductivity at microscopic levels. The results reveal that lunar dust is not inert. Its particles form transient bridges of charge when heated, linking and unlinking billions of times per second. The moon's dust behaves like a primitive network, an electric field in constant reorganization, fragile yet alive with motion. It is a chaos that knows balance. On Earth, the discovery leads to research into self-regulating materials, surfaces that can store and release heat without external control. The moon once again teaches by example. As the light strengthens, the shadows of Atlas's structures stretch far across the ground. One camera turns inward and captures its own silhouette framed against the horizon. It is a simple image, a machine standing solitary on a sea of gray, but in that composition lies an entire philosophy. The figure, stark and symmetrical, mirrors the ancient monoliths of Earth's early civilizations, though it was built not for worship but for knowledge. Still, the resonance is inescapable. Both speak of longing, both reach towards something unseen. The engineers who see this image later describe it as a portrait of continuity, an unconscious echo between ancient stone and modern alloy. Throughout this phase, Atlas begins to record low-level seismic activity again. The signals come irregularly, faint shivers that ripple through the crust. At first, these seem to correspond with tidal stress from Earth's gravitational pull, but analysis reveals a subtler pattern. The vibrations grow slightly stronger at points where the subsurface metal veins intersect, as if the moon itself were transmitting currents through its skeleton. The machine amplifies the signals, recording them as waveforms. When the data is converted into sound, what emerges is strange. A pulsing resonance not unlike a heartbeat, layered with harmonics that rise and fall in patterns of mathematical regularity. It is not biological, of course, but the resemblance is haunting. Scientists on Earth replay the recordings in laboratories, calling it the pulse of stone. For those who listen, it becomes impossible to think of the moon as dead again. The rovers continue their survey of the nearby crater field, their wheels stirring faint clouds of dust that fall almost instantly back to the surface. Each grain settles exactly where it began, as though gravity here refuses even the smallest rebellion. One rover on its outward journey encounters a fissure that emits a barely detectable current of gas, argon and helium venting from deep pockets below the crust. The discovery challenges long-held assumptions that all lunar outgassing ceased billions of years ago. Atlas focuses its instruments on the fissure, watching the slow shimmer of escaping atoms. They drift upward and vanish, absorbed into vacuum. But for a brief moment, in the border between solid and void, the machine captures the chemistry of an ancient exhalation. Somewhere beneath that surface, volatile elements still persist, trapped in frozen fractures. The moon, though ancient, continues to release its memories in breath too faint for any ear but a machine's. Back on Earth, the transmission inspires debate. If the moon still releases gases, could it still contain reservoirs of volatile compounds? Could these be harnessed one day, not for exploitation but for study? The implications ripple outward through universities and think tanks. The question is not about colonization now, but participation. If the moon continues to change, however subtly, it demands not ownership but guardianship. Atlas has not simply revealed geology, it has revived ethics. As the long lunar day reaches its midpoint, light saturates every surface. The machine's temperature regulation algorithms hum steadily. It turns its cameras skyward to observe the scattering of solar radiation across the thin exosphere. Though nearly imperceptible, the light forms halos that shift color with altitude. The sensors measure refractive gradients so delicate that each frame of data resembles a painting, a blur of gold fading into indigo, then into black. Atlas's optics were designed for precision, not beauty, yet beauty arises from precision itself. The images, when transmitted, are displayed in planetariums across Earth. Audiences gaze upward at the moon projected before them, seeing it not as cold but luminous, alive in hue and contrast. The machine, designed to see without emotion, teaches feeling through detail. Late in the day, Atlas begins a deeper scan of the subsurface magnetic anomalies. Using the interplay between its magnetometer and the rover's relay signals, it triangulates faint distortions. These distortions, mapped over weeks, reveal complex geometries, loops, knots, and arcs that thread through the crust like veins of invisible fire. Each loop corresponds to an ancient lava tunnel now filled with iron-rich rock. The geometry is beautiful and impossible to predict by standard models. It suggests that the moon once possessed not random volcanic outflows, but structured channels of molten flow guided by gravitational feedback. The planet shaped its own rivers of fire with astonishing order. For scientists, this insight reshapes theories of planetary cooling, but beyond that, it offers a poetic revelation. Even in chaos, nature builds symmetry. As twilight begins its slow descent, shadows lengthen again. The rovers return to base, their paths crossing in precise arcs calculated to avoid dust contamination. The low angle of light transforms every footprint, every track, into a drawn line of shadow, temporary yet deliberate. In a few weeks, these marks will blur away, and the surface will again appear untouched. Atlas records their fading every day, frame by frame. To human eyes, it may seem futile, but the lander's archive will one day show the exact rate at which time erases action on this world. It is an experiment in impermanence, a study of how memory decays even in a place without weather. Night comes slowly on the moon, not in minutes, but in hours. The temperature begins its free fall. Before the lander sleeps, it directs one last scan toward Earth's glow. The pale blue light glimmers across the crater rim, illuminating dust motes that float briefly above the ground. They drift like ghosts, tracing invisible arcs in the thin electric field. The lander's sensors capture their movement, each trajectory a delicate curve that describes gravity itself. These dust trails, when modeled later, help refine humanity's understanding of small-scale gravitational interactions in low-atmosphere environments. But the visual itself, the soft dance of light over dust, stirs something deeper. Even the smallest motion here carries dignity, as though the moon itself acknowledges the patient observer that keeps watch over it. Now the power begins to diminish. The panels angle downward, internal systems dim to conserve heat. The last data stream travels across the void, carrying images of dusk. Numbers that describe cooling, graphs that trace the last vibrations of the crust before stillness. On Earth, the transmission ends in silence. The scientists mark the completion of another cycle, noting that everything is as expected. Yet expectation cannot contain the quiet magnitude of what has unfolded. Each awakening, each sleep, adds to a continuity that no single generation can own. The mission exists now beyond its creators. It is part of lunar time itself. And as the darkness thickens, the machine stands unmoving, waiting for light to return. Inside its casing, residual warmth lingers like memory. Outside, the stars crowd the sky with ancient brightness. The moon holds it, keeps it safe in its infinite patience. Somewhere on the far planet, a new group of students learns about Atlas, reading the data it left behind, preparing to continue the dialogue when dawn comes again. There will be new instruments, new watchers, but the same silence, the same rhythm, the same enduring conversation between light and dust, between question and witness. The story does not end. The lander sleeps, but time does not. The moon turns slowly under the steady gaze of the sun. And already across the edge of its horizon, the first photon of another morning travels toward the crater, carrying with it the quiet promise that 3I Atlas will rise again. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on 3I Atlas heading toward the moon again? We want to hear from you. Thank you for watching, and see you next time.